I had an approved application about a year and a half ago. I just never got to take the test.
All right, good morning, everybody. Welcome back. Day two, you came back. Someone else here. All right. Thanks for coming back. Rolling. It went super fast for me this week. But we're back together doing this again. I was so excited. Yesterday, I got a message from someone who took the last class that we had in this room, actually. And he said, I'm doing a stakeholder register. I went to an old project that was very similar to ours and pulled up their stakeholder register. And I was like, oh, look at you go. Look at the stuff we talk about here, right? But I don't like the way they did it. And this is what I'm thinking is, which is the right way? And I know it's just for me, but it's a deliverable. So I want to make it right. I'm like, look at you using all these terms. So proud. So welcome back. Welcome back. I hope that you get the same thing. You're like, oh, here's things that are great tools that I'll be able to use. Okay, I thought I would start off with a review, and like tradition has it, my computer, once it stops, doesn't like to roll again. All right, I just put in a couple review slides. So the definition of a project, it is a unique, right? There's the word. It is a unique product, service or result. First gold star. So it's time boxed, right? So boxed in by time, start and stop date. It drives change, right? And enables value. Those are the key pieces. So I want to know if you're going to take the test. All right, for a traditional approach, it's plan-based. So all the requirements are known, so we can make a plan. There's a project manager. There's a project sponsor. Those are people with the traditional approach. With an adaptive or iterative agile approach, the requirements are not well known, so we can't make a detailed plan. We have a product owner or a project owner and a scrum master. Key positions with the agile approach or iterative adaptive approach. We talked about all the documents that are created and the action that happens before a project actually begins. So we do a needs analysis. We talk about the value we're trying to create. We talked about 6 different values. We do a benefit management plan on how we're going to ensure that we get those benefits we want from our project. We then create the business case, which leads to the charter, and that's a test question, at least one of them. The business case leads to the charter. The charter kicks off the project. The charter allows the project manager to allocate resources, spend resources. And then we had a few terms like OPA, like all together, OPA, which is our processes, policies, artifacts, documents. They're all OPAs. EAFs, everything that happens in the environment that affects our team, but out of the control of our team, so external environmental factors. We talked about definition of ready. We have everything in place, ready to go, agile term. And then the other agile term, definition of done. How do we know when to stop? How do we know that we can stop our project, that we've met the requirements we intended to do, the definition of done? Then we talked about stakeholders. Remember, all stakeholders are important. None of them are less important than the others, and we'll get left out. We talked about identifying and documenting stakeholders, and our stakeholder register is the tool that you want to use there. Remember, associate it with identify and document. Analyze stakeholders, the power interest grid we covered, and analyzing stakeholders along with salience model about engaging stakeholders. We have a SEAM, maybe called a SEAM, SEAM, or Stakeholder Engagement Assessment Matrix. And that's the C and the D matrix with current and desired. And then we talked a little bit about stakeholder communication, challenges with communications, the model, how to figure out the number of communication channels. And we talked about the term information radiator. That's what we have here in the room, some information radiators. We also covered a lot of material we covered, right? Scope, and there's the definition of scope, the features and functions that characterize product, service, or result, definition of a project, or the features, functions that work to characterize the delivery of the project. And then we were talking about requirements when we left, but we talked about identify, document requirements, some different types of requirements. the categories there that I've listed, and the tool of a requirement traceability matrix. Okay. That was a lot of material that we covered. And we left off on slide 121 in your book. So now my slides are numbered differently because I threw in those review slides. And I decided to say that. I know you guys are all smart enough to figure that out, but there's always someone in the class that goes, my slide number is different than yours as we get rolling. And I have to go, yes, remember I added some slides in my deck. But keep rolling with your slide numbers. You're fine. I didn't change any of the slides that are in your book. Okay. Picking up where we left off, slide 121. We were talking requirements mostly in a traditional approach. And so this shifts us over to the iterative, adaptive, agile, rolling wave approach. All the same name or same approach, right? So our requirements are our backlog items. Simply the backlog is where we find our requirements. And so because they're not known and they're identified throughout the project, our backlog keeps changing. And so we do refinement meetings where we look at our backlog to go, are these items still relevant? Maybe something's changed that's made them not relevant. Are we missing any? Are some big that we're going to separate into smaller items, right? So we'll take our quarter and divide it into 5 nickels instead, and refine our backlog that way. We refine the acceptance criteria. So that's the standard that we're going to work toward. The acceptance criteria is what our stakeholder says, I want you to do this project so it accomplishes this function or to this standard, to this quality. Then they'll like, oh, you did it. Great. I now accept and can say this work is done. The product owner, along with the team members, decide which backlog items get pulled into a sprint. We talked about that, right? That one's important, I guess. So I didn't say the Scrum Master decides on the backlog items, right? So the Scrum Master, part of the team, but their job is to optimize performance. So their job isn't really to help identify requirements or manage requirements. It's the product owner or project owner that owns the backlog. So it's the product owner that's responsible for identifying and documenting all those requirements. Product owner owns the backlog. So they're ultimately the one responsible for identifying the requirements. So in an iterative approach, you end up with a long list of things you need to do. And how do you know which items you're going to do first, second, third? What goes in this first sprint? What goes in the sprint after that? What do we do first, right? So in an iterative approach, we prioritize our backlog items to decide what it is we're going to do. In a traditional approach, we just make a plan. We plan out when we're going to do all of them. But in an iterative approach, we prioritize our requirements to decide when we're going to do what's most important to do. And so we're going to talk a couple different ways of how we prioritize requirements in an iterative approach. So here are, I think, 6 different ways we're going to talk about. 4 on this one. Moscow. So Moscow is an acronym where 4 of the letters are important. The other 2 just make up the word, right? But with Moscow, we say, now again, we're talking products like software development or product development for Moscow, right? So here are the features, or here are our requirements that we must have. That's pretty important. We must have them. Here are requirements that we should have. Here are requirements that we could have. That would be nice to have, right? And here are requirements that we won't have. We're not going to do this. So this is, you don't really see that as a requirement. Don't do this. You see it in the scope. So that's where you see the don't do this. Our project's going to do these things, but it's not going to do these others. But this is prioritizing must have, should have, could have, won't have is Moscow. You'll see that on the exam. Then we have the Cano model. And the Cano model is talking about features and what features should really be on our product. The Cano model says some features are delighters or exciters. Those are the ones that are going to cause people to line up outside the door at 4 a.m. waiting for you to open so they can run in and get your product. Right? So those are really important ones. Then we have satisfiers. That makes the product good. We have dissatisfiers. Sometimes we can't avoid that. Don't really like it, but that's what we have for whatever reason. And we have those that are indifferent, like it doesn't really matter. So the Cano model says delighters or exciters, satisfy, dissatisfy, and indifferent. Right? So those are the 4 descriptors of features for a project. We have a paired comparison analysis, and paired comparison is really requirement number 1 and requirement number 2. Which one takes priority? Okay, requirement 1, requirement 3, which one takes priority? Requirement 1, requirement 4, which takes priority? Okay, let's compare 2 to 3 and 2 to 4. Now 3 to 4. So we just compare one to the other. We may rank them, 1, 2, whichever has the most ones becomes the highest priority. It works with a small number of requirements. I had to do this once with 144 items. It took hours. I had to stop and come back to it. It was miserable. Don't do that. But if you have, I don't know, maybe 10, it's probably okay. Right? But with a lot, oh my God, this method is awful. All right, 100 points method says everybody gets 100 points. And here are our requirements that we're considering. Give them points. So you can take your 100 points and distribute them any way you want. You can give one of them all 100 and the rest of them get no points. You can give all of them 4 points. You can give 120, 117, 16. And so everybody's going to give all of our requirements points, and the one that has the most points we'll say is the highest priority and so forth. So we can rank them that way according to our points. All right, 2 other ways. Voting. Thumbs up, thumbs down. We vote, yes, no, is this a priority, right? And then the multi-criteria decision analysis matrix is, we have our, perhaps our requirements across down the left-hand side. So I'll put them this time. Our requirements down the left-hand side and our criteria across the top, and we're just going to rank them. So it may be that I'll rank them 1 through 5, or I'll rank them 1 to however many there are. Or I'm going to score them 1 to 5. And then whoever has the most points or the least points, however we're scoring, is that right? But it becomes a matrix where we're comparing our criteria to our requirements in order to evaluate which is the highest priority. So there's 6 different ways that we prioritize requirements. This next slide talks about depicting requirements. On the far right side, I guess, as you're looking at it, prototyping is really, I think, the way of depicting scope. All my requirements together, this is what we're trying to create. So we create a prototype of whatever it is, our little building, we saw a prototype in our video last time of the Bradley fighting vehicle, was it? What did it end up being called? Our tank troop carrier. So it's a prototype, right? It's a model of what we have. And that really shows all the requirements together and shows our scope. This is what we're trying to do. The other items help us show how we came to all of our requirements. I think that's the best way of saying it. But mind mapping would start with this big orange dot in the middle. Here it says energy. And then we said, okay, what about energy drives the requirements? And they came out with 3 other smaller categories that are the smaller orange ones. And then from there said, okay, well, what about this little orange one? And came up with 3 ideas. And then the second one, what about this little orange one? And came up with more ideas. So it kind of shows how we've broken something big into smaller pieces to identify requirements. What you need to know for the exam, for those of you taking the exam, is mind mapping is a way to depict requirements. And it'll look something like that. It's just a way to depict requirements. Affinity diagram is associated with Post-it notes. So those are the words you'll look for on the exam. The diagram depicting requirements using Post-it notes is affinity diagram. And so everybody is putting their requirements on a Post-it note and we're putting it everywhere. And then we're sort of grouping them into themes. And then we may prioritize the themes from there. Now, rarely do teams use actual Post-it notes anymore. They're electronic Post-it notes. But we'll take all the requirements, group into the themes, then we can prioritize based on our themes. And the themes may be a feature of a project. Maybe they're grouped by the users who use the software system. They can be grouped multiple different.
It's more of a way of grouping requirements,
It groups requirements and then,
a whole bunch of small requirements to
yeah.
large.
So we're going to see how they relate to each other.
Got it.
With an affinity diagram. The context diagram is used to show how they all work together as a system. So a context diagram shows the system of what we're trying to do, that they all, different pieces relate to each other, including the people. So the people involved in the process, the developers, the users, are reflected in a context diagram. So if you're taking the exam and it wants to know what diagram depicts requirements, including people, don't even read any of the answers, just pick context diagram. You don't have to read the rest. Okay, read them, but the right answer is going to be context diagram. Okay, that's the key part to remember that one. It includes the people in the process. So this was supposed to be removed from the exam. I'm not 100% convinced that it is yet. So if you're not going to take the exam for like 6 months, you probably won't see this on the exam, but if you're going to take it really soon, maybe 30% chance you may see this on the exam. So this is like, how do we identify requirements from a product? And then we're going to prioritize different things. So we can actually look at the product and break it down by its components, and then we'll figure out what all the requirements are from the components. Systems engineering, we're going to look at whatever it is we're creating as a system. So the product itself plus the environment it works in. We may look at it as a system for its life cycle, from development all the way through maturity, decline, and all the requirements that happen there. So if we know we're going to build something and have a sustainment piece to it afterwards, we may look at all of those requirements from the life cycle perspective, from a systems perspective. Systems analysis, really, what are we trying to get to in doing the analysis part? What's the end goal? And then we back up from that. The requirements analysis, this is funny because we're talking about requirements, but the specifications. So let's put specs to our requirements. Value engineering is optimizing its value. Value is a relationship, a ratio between costs and benefits. So value is really this relationship. Value engineering, value analysis, pretty similar. You don't need to know the difference here. If you're going to use one of these methods, you'll know the difference. But engineering, we're creating something. Analysis, we're really just trying to do an analysis that's going to lead to creating something. So value analysis, what can we do so that we can get the most bang for our buck? So if you're going to take the exam with product analysis, I think if you just know, if you can recognize these 6 items and that they're part of product analysis, it helps us get to identifying requirements or prioritizing requirements is all you're going to need to know for the exam. Okay, so we have identified all of our requirements. Now we're going to break those down even further. Okay, so requirements are generally higher level and they consist of tasks and activities. So requirements in and of itself doesn't tell us what we need to do. So this is like the PMI line, and it's really hard for me to say this because we just talked agile, right? In a traditional approach, we have requirements, and then we're going to break them down to tasks and activities in a different format. In an agile approach, we can't stop at requirements. They're too big to do in a sprint. So we have to break them down into those smaller pieces that are tasks and activities. And so the backlog of an agile project really are tasks and activities. We start with requirements, but we have to break them down into their tasks and activities. The traditional, we generally don't do that. We stop at requirements. Okay? So two differences between the different approaches. So we're going to talk traditional because we're going to say, oh, we know all of our requirements, so let's organize them. So to know all of our requirements means it's a traditional approach. So through the process of progressive elaboration, which is a vocabulary word you'll want to know, which means progressively elaborate. I'm just going to continue to expand. I'm going to continue to break this down into smaller pieces. That's progressive elaboration. So through this part, we're going to organize our requirements. So we're going to start working on what's called a work breakdown structure. I'm going to show you that next, but there's some terms missing. So I started making up terms. Years ago, I started making up terms. It hasn't caught on yet. I'm sure it will, though, if I just keep at it. So at the top of our planning chart, we have our project. And now what are the requirements of our project? And we're going to break that down and organize it. Now we can organize it any way we want. And that's the chunks. That's what I'm like, what are the chunks of the project? How are we going to break this apart into big pieces? So I started calling it chunking because I'm like, what are the chunks of our project? So this is Julie's term, chunking. I catch on, I'm pretty sure. Chunking. So, and it may be the deliverables, but what are the big pieces of our project? So you can break that apart. Here's a few of them by time. So what's going to happen in January, February, March, April? Maybe fiscal year 24, 25, 26, 27. Maybe your time is Monday, Tuesday, Wednesday, Thursday, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, however you're managing your project, right? We can break it down by time. Maybe it's by phase 1, 2, 3, 4, because we know that different things happen as we move through our project. So we're building a house. Phase 1 is dig the foundation. Phase 2, we pouring cement and walls. Phase 3 is going to be electrical and plumbing. Phase 4 is going to be, right? So we can break it into phases like that. It allows us to schedule resources appropriately that way. We can break it by function, marketing, human resources, accounting, different functions we have. Agency or department or J1, J2, J3, J4, could break it apart that way. The requirements for all of those pieces. Anything that's easy for your team to remember, anything that's easy for you to manage, you can break it apart here. So we start creating a work breakdown structure when we have some organization. So at the top, okay, this chart just went crazy on me all of a sudden. We have our project, and we're going to do a professional development conference. That's the project we're going to work on here. So I don't even know where that other piece came from. For our professional development conference, I decided to break it apart by function. So my first function is facilities and audiovisual. My second one is food and beverage. I have presenters coming to my conference. I have people coming to my conference. So I call that guest relations for everybody who's attending my conference. And then someone who's going to go get us money to do our conference, to do sponsorship. Right? So those are the pieces that I have for my conference. And then, so those are the chunks. That dark blue level are the chunks of the project. Underneath that, I have what are the activities? What are the requirements? Let me get my words right. What are the requirements for facilities and audiovisual? Like, how do you do facilities? What do you mean? What are the requirements for facilities? So here my requirements are, I'm going to block rooms at a hotel. I'm going to get some rooms for our VIPs and make sure they're blocked off and paid for. I'm going to get a conference center, breakout rooms, audio visuals. Make sure I have all of the audio visual equipment I need. Under food and beverage, well, we're going to have some food and beverage breaks like coffee and donuts in the morning. We're going to have some formal events like dinners at night where we'll have a speaker talk. So what are the requirements underneath these different chunks? And that's what we're going to put there. So here I looked at my conference and I decided to chunk it a little bit differently and went just before, during, and after. So before the event, so this would be by time. Before the event, these are requirements that I have. During the event, here are my requirements. After the event, here are my requirements. Now, because I'm not the smartest person you'll ever meet, I always take my event or my project and I look at it by function and then I look at it by some other way too. Because when I did it this way, I started identifying more requirements. I'm like, oh, wait, afterwards we have to pay the bill. There's a report that somebody wants to see about how successful this conference was there. So I started identifying more requirements when I started looking at it from different ways. So that's just one of the techniques I use to help me identify all of my requirements. So here's broken apart by phase. Phase 1, promotion. Phase 2, facilities. Phase 3, coordination. That's where we're locking everything down at that point. Phase 4, the conference happens. Phase 5, we're closing it out with all of our contracts and just another way of looking at it. And you'll notice on this chart, the third layer has numbers because it's easier to track is why. So I have numbers here. We have work. This layer has a name. So the dark blue layer does not have a name. I call it chunking. These are the chunks of my project. But this third layer has a name. We call these work packages. So the work package is the lowest level in a work breakdown structure, which is what this chart hierarchy diagram is called. A work breakdown structure, or WBS. And on the exam, you may see WBS and you may see work breakdown structure. There's a question out there about WBS stands for, and you have to know it's work breakdown structure. If you can't remember it, skip it, because you're going to come to another question about a work breakdown structure and you're going to go, oh yeah, that's right, that's what it stands for. And then you'll go back and answer the other question. It'll give you the answer. Can you go back? You can go back. Yeah. Within a group. We'll talk about that, but you can go back.
Oh, okay.
Yeah. So these work packages, the lowest level of the work breakdown structure, and normally it's just free. Sometimes these requirements are so big that you may see a fourth level. I don't know if I've ever seen more than a fourth level. It's normally just 3 to get the requirements. But know that the work package is the lowest level in a work breakdown structure. So work package 1.1, work package 1.2, 1.3, 2.1, 2.2. So these numbers here just help organize the work breakdown structure, label it. So I may have a project manager for the conference and a team lead for each of these areas. So I have a team lead for promotion, a team lead for facilities. And so if I see work package 2.2, then I'm like, oh, that's facilities because it's 2. My team lead is this person. That's who I'm going to go talk to if I have questions. So those are the numbers to help organize our chart, to name them. So I know where they fit in the organization. However, there's another set of numbers that you want with each work package. And I'm going to tell you what that is in a minute. I think it fits into a better place here. So work package, lowest level in a WBS. You get there through the process of progressive elaboration. Those are the test questions there. Can you say it again? The work package is the lowest level in the WBS. You get to a work package through the process of progressive elaboration.
That's basically everything you just described going through the chart.
Yes. Now, for agile, the process of progressive elaboration is backlog refinement. They call it backlog refinement. Refining our backlog, breaking it down into smaller pieces is progressive elaboration. Now, we have our work package, but those are requirements. And so it doesn't necessarily get to the level that somebody really knows what to do if they look at that. So we actually add something to those work packages that we call a WBS dictionary. And the WBS dictionary, every work package has a WBS dictionary. Okay? So this can be quite a lot. You see, in a big project, you may have 100 work packages. Every work package has a WBS dictionary. The WBS dictionary, this is where the other set of numbers comes in, has a lot of information that whoever is going to be doing the work is going to look at the WBS dictionary to see what needs to be done. So that's where they're going to find all kinds of things that they need to know. There's one item that must be in a WBS dictionary according to PMI, and that one item is the code of accounts, which is an accounting code. It says the color of money that gets used for that work package, basically. So they call it a code of accounts. It's an accounting code. And that's the item, according to PMI, that must be in every work package. From there, you can have any other information that you want that tells the user how to do whatever is in that work package. So we can have a description of the work. It can have, here's the vendor we're going to work with. Here's our contact information. Here's a deadline of when you need to contact them by. Here's milestones, resources you need, cost estimates, whatever you want to put in your WBS dictionary that tells the user, it tells the person on your team, it tells your team member, what they need to do to accomplish this work package. Okay. Now, every work package has to have a code of accounts and only one code of accounts, only one. You can't have any more. So if I have a work package that is about the speakers, and the speakers are we're paying for their travel and we're going to buy them a gift. Because of the way my accounting system's set up, travel money is different than my money that I used for gifts. So they're going to have two separate accounting codes, which means buying a gift for my speaker and coordinating travel for my speaker need to be two different work packages because they'll need two different codes of accounts. Okay, every work package can only have one code of account. But I may be buying gifts from my speaker as well as the attendees. Right? So my code of account can be repeated in different work packages. So that code of account could show up in multiple work packages. And each work package only has one code of accounts. Okay? So the same code of account can be listed in multiple work packages, but each work package only has one code of accounts. That's a test question that's poorly worded, so it seems a little confusing. But if you think color of money, right? We only have one color of money for each work package, but that same color can be repeated throughout our WBS. So this is from a project management software program that puts their WBS electronically. It's a little bit hard to read, but task number 1 or number 2. So this would be chunk 1, chunk 2, chunk 3, chunk 4. And then here's my work package underneath chunk 1, my work package is underneath chunk 2, my work package is underneath chunk 3. And then I would detail it out with whatever information you want on those columns. Now, I should throw in a picture of our requirement traceability matrix. And it started out with something very similar over here, right? Of tracing our requirements, tracking our requirements with a 1, 0, 0, 1, 2, 3, 4, and then further on down. So it kind of matches up with our work breakdown structure. So the requirements traceability matrix is where we're listing all of our requirements that we're tracking. The WBS dictionary is where we're putting a lot of details about how we're going to do all of those requirements. It will list tasks and activities to do in the WBS dictionary.
We put the definition of done for each task inside there too.
You could, because, but you don't, for a very simple reason. You absolutely could, okay? The definition of done is an agile term. This is used when we know all of our requirements, so it's traditional. So it's two different vocabulary. However, as agile is being used more and more with a lot of different projects, our terms, our meetings all start being borrowed from each other. So if you want to put definition of done in the WBS dictionary, why not? You can call it acceptance criteria, same thing. Okay, questions about a WBS dictionary, the WBS, how we get to a WBS. So the work packages are requirements, and then the task and activities to do those requirements are found in the WBS dictionary. With Agile, the task and activities are in the backlog. That makes up the backlog. We'll start with requirements in the backlog, but as we start planning the sprint, we got to break them down into tasks and activities. So eventually our backlog is a combination, but the task and activities is what we try to get to.
Agile, do you break down the task and itineraries into chunks like you do, like we just went over with the traditional method? That makes
Generally, you don't know all the requirements,
of course.
but when someone says, you kind of do.
Yeah.
Because we want to build a software program. Okay, well, what's it going to do? Well, it's going to do these kind of things, and we'll start talking about features. And in a way, that sort of becomes the chunks of it.
Makes sense.
Yeah. Okay, let's go all the way back to the beginning. We talked about the 10 or 11 parts of a project plan. So there are 10 management plans of a project plan, now maybe 11. We've thrown in compliance. There's 11 of the 10. 3 of them have baselines. Remember, scope, schedule, and budget have baselines. This is how we get to our scope baseline. So it is our scope statement that we talked about. We did talk about scope statement, didn't we? Suddenly I'm like, wait. But our scope statement is the sort of executive summary of our project or our event, plus our work breakdown schedule, plus our WBS dictionary. So you end up looking at all 3 of these when you ask the question, are we in scope? Are we still in scope? Are we doing something we shouldn't be doing? That's what the baseline's for, to make sure we stay on track. In order to know that for scope, we have to look at all 3 of these. So test question, the scope baseline consists of 3 items: our scope statement, which is like the executive summary, our WBS, and our WBS dictionary.
Can you say that again, please?
Our scope baseline consists of the scope statement, our work breakdown structure, our WBS, and our WBS dictionary. Those 3 items. So to say, are we in scope? Or is this task out of scope? When someone says, hey, I have a good idea. What if we do this? You're going to be like, does that fit in this project or not? And it's one of these 3 documents or a combination that you're going to check to see if you're in scope, if that ask can be done. So we have a certain picture we're trying to create. We've got to assemble all the pieces And if we add this piece, is that gonna change our picture? If it's gonna change our picture, we don't want to do it. Okay. Tell me at TRANSCOM, what projects you've worked on that could have used the WBS? All of them? Can you think of any where you're like, wow, we should have broken this down and planned it out and known the pieces and divide and conquer?
We're doing that with TCA, right? Like we've broken TCA, the Transcom Anywhere project that we just started, very similar to what you're describing.
TCA, TRANSCOM Anywhere?
Yeah, Transcom Anywhere. So it's the new, one of our new initiatives, that the engineering team's working.
Okay, and so you created a WBS, working through that process now. So you identifying all the requirements and then how do we all fit together here?
Yep.
So, good. So a WBS doesn't make sense for an agile process because it would look like this. Here's our conference, sprint 1, 2, 3, 4, and then all of our backlog items over here. So they don't. Yeah, it doesn't make sense for an agile project. So we don't do a WBS for an iterative or agile approach. Instead, we do epics, features, and user stories. We have epics, features, and user stories. Okay. I think we've talked about all of these already, right? Our requirements, the tasks and activities that make up the requirements of the backlog. We do release planning, which is kind of what Chris asked, right? So we'll say, here's our big picture. We'll break it down into chunks that we'll call releases. This will make our release. So let's break it down into our iterations. How are we going to know what iteration 1 is, or iteration 2, or iteration 3? We'll call those iterations a release. So in a way, we create chunks. But with Agile, they got new names and they named everything, unlike traditional, right? So they're called releases. They're kind of the chunks. And then how many sprints should be in a release? And we'll plan that out, right? And then the sprint planning meeting talks about what we're going to do in this very next sprint. So epics, features, user stories, we're going to talk about story maps, roadmaps we're going to talk about. And then again, let me emphasize that the product owner, along with the team members, select the items that will move forward into each sprint when the time comes. Okay, let's talk about epics, features, and user stories. Does anybody here use epics? We talk epics. So an epic is a big body of work, right? It's not necessarily an iteration. They're not iterations. And we can't even really say that user stories make up features and features make up epics. It doesn't quite work that way. Unless you guys use it that way. It doesn't really work that way. But an epic is really a large body of work. You can't even, it's just a large body of work. I think that's where we just need to stop, right? So you don't even take your project and break it into epics, like trying to put it in a WBS. It doesn't really work that way either. How do you guys use epics?
Well, so our epic, so specifically for the TCA or the Transcom Anywhere project, there's a number of different epics that we've created, like deploying the mission landing zone would be one epic. And then we've got all the different tasks that need to be completed in order, or need to be done in order to complete that. And then we've got Entra ID, which is another one. And then we're still building the backlog and all the different stories, but we've used the epics as like the larger
chunks of the project.
The kind of like, yeah, the larger milestones that we have to meet. I'm wondering now if we didn't.
No. So you're just going to look at like, here's a big part of this project. It's a big part of the project. So you can have 1, 2, 3, 4 epics within an iteration. It's just a large piece of the project. So we're just able to label this part, right? It's going to drive requirements. It's just a big chunk. But don't think of it like, don't try to relate it to a WBS because it doesn't really relate that way. An epic consists of several requirements. I think that's all you need to know. It's much easier when you start working it. It's just a big piece. We're just going to describe this big piece because it's a function of what we want our project to do or what our project's going to be, right? So it's a function of it, but it doesn't really relate to an iteration. It's just a large body of work.
Like on the house building model, a foundation would be an epic because that's a large piece of breaking down the process of building a house.
Could be, but we're going to use a traditional approach for building a house. And so we're going to call it something different. The epic might, for building a house, an epic might be, can't even make myself combine those two together with a traditional and.
It might be like, okay, so the traditional approach would be, you know, building that foundation and all that stuff. And then the epic would be how the grout on the tile would be for the owner, the new owner. The owner tells the story to say, hey, I want my countertops to be granite and I want the backsplash to be stainless steel and I want these things. You know, and then as a developer, you have to create that image to it because you already know you're going to build the kitchen. How does the
Yeah, so this is what's difficult about it because you already know. So the requirements are known there, what you're going to do. But here the requirements aren't known. So like I need a place to live. That's all I know. I need a place to live. Right.
Yeah.
So with an epic, because you don't know the requirements, you're going to describe it in a general way that's becomes a large body of work that you're then going to go, okay, now how do we do that? What are the requirements from that? So it's reversed because we don't know the requirements. So and that's why it's really hard to put that in building a house. We know all the requirements.
Sure.
So if you didn't know the requirements,
You like provide affordable housing or something.
yeah. So an epic may be a structure that you can live in. And a structure for my vehicles to live in. What does that mean? What are the requirements to create a structure for that?
Gotcha.
Right. So that's why the epic, it becomes so generic. It was really hard for me to translate. Sorry if I didn't.
Yeah,
Sorry.
it's, so we kind of did this in Saudi Arabia with PSAB. We walked around with General Sullivan in PSAB and he would just do user stories. This is what I have. This is what I'm thinking. This is what my, envisionment is, right? This is what I'm thinking. We would write his stories down and we created, hey, the epic is, take his user stories and make it into a picture for him so that he could then turn around and approve that. And then eventually we got to the point where, okay, we know all the requirements now and we switched to a traditional method where we designed it as an engineer project and built it.
Yeah. So if you don't know what you want, how do you start describing it so that you can figure out what you want? That's the idea of the epic. It's how the human brain works. We gotta label things. We gotta name it. So we have to start somewhere, right? So what's the big thing that we kind of want? This big story, big idea. And then from there, we break it down to derive requirements and then task and activities. Yeah, go ahead, Augie.
So the features and user stories, they can cross epics. Right. So if you look at it from a project, from a more like a software development thing, you have a feature that is something you want your program to do, and that's going to take from like a security epic and user interface epic and all that. And then how the user uses that is going to cross features.
So there may be it gets down to a task that a developer does that feeds multiple epics.
Yeah.
Yeah. So that's why there's no line connecting between them. Thanks. There is a task that could help build out multiple epics. Okay, who online have I really confused?
be honest, I'm still a little confused on like the feature.
Yeah, we'll get to there. So we haven't
Okay.
started talking about it yet.
Okay.
I'm just trying to blabber through what an epic is here, failing miserably. I'll tell them, I failed miserably at that part. So, okay, large body of work. How we're gonna start to break down our project, because we don't know what we're gonna do yet. We know just, we're gonna make this happen. All right, a feature, smaller part. This says a smaller part of an epic, but it's a smaller part, it's a feature of an epic. Because this feature may feed multiple epics, it's been said, right? But it's gonna connect to an epic somehow, right? So from this, we're like, okay, we need this function to happen. Again, software development, it's gonna have these big pieces we're looking at. What are features that can be managed? Our user stories feed the features. The user stories combined will make this feature happen. So a user story is a task a developer is going to do, but they're not going to talk about it in developer language. Coding, creating this, the mechanics of how to do it. They're just going to say, after I do all of this coding magic that they do, you will be able to have a dashboard that you can customize and sort and move columns around and add and delete columns as you want. And so you're going to talk about the task to be done from the user's point of view, from what they're going to see in the software system. So that's the user story. So a developer will say, in this sprint, I am going to do the task that allows you to, the software system will be able to, from a user's point of view, have the button located on the left-hand side and be larger than what we currently have because you've asked us to change that around. So that's what I'm going to do in this next sprint. Customize and change the background colors because we didn't like that. So that's not developer language. They've got to push buttons and code and do all behind the stuff. But a user story is told from the user's point of view. This is what you'll be able to see about the system, what you can do from the system. That's the user story. And then you put user stories together enough and you have a feature of your software program. Okay.
How does your backlog relate to this?
So the developer is going to do a backlog item and phrase it as a user story. So the user stories are really the backlog items told from the perspective of the user. So meetings I've been part of. The developer teams always end up with really cool names, actually. So, Dragon's Breath, Team Dragon Breath. Team member 1 says, for this user story, you will be able to see, I'm just going to stick with the same example. You will be able to customize your dashboard. You'll be able to sort by 3 different ways. You'll be able to add and delete columns, and you'll be able to move columns around. Do you accept this user story? And then the stakeholders or the users say, no. I don't want to be able to sort by 3 different things. I only need to be able to sort by location and alphabetic. So just 2, only sort 2 ways. Okay, let me change my user story now. Now, because he's going to change what he develops, right? So, okay, now my user story is at the end of the sprint, you'll be able to sort 2 ways and add and delete columns and move your columns around in different orders. Do you accept this user story? And that's when the user, the stakeholders say, yes, I accept that story. That creates definition of done. That's how I know I'm done with this task when my software program will sort 2 different ways, add, delete columns, move columns around. Make sense? So it is a backlog item. We're just not talking about it in coding language. Story maps. You should find the video for epics, features, and user stories too, because this video explains story maps much better than I explain it. So we're going to watch the video. Find someone who explains Epic's features and user stories much better than I do. If you're online, let me know if you can't see or hear the video. Oh, wait, I know you can't because it popped up on the other screen. Oh, good. Oh, good. We're gonna get the sound to play without the echo. course not. I have to sign it. Okay, hold on a minute. I gotta put this. Back at it. Everybody back online. I'm supposed to not pop something for the cameras here. So for those who are online, couldn't hear the videos, in the email that you received with the slides, the video link is in there, so you'll be able to watch the videos, but Shannon put it in the chat as well too. So if you're in person and you want a link to the videos, because obviously that's not a link in the book here, you can send your personal email or work email, whatever you want, to either training@scaleraeducation.com or to Shannon's Gmail address is sfellamer24@gmail.com, and he will send you the links to those videos as well too. But I think if you guys also received the PDF that has all the slides in as well too. So you have the link there as well too. Go ahead.
That will be for the videos that we're editing for classes.
Oh, the videos for here, not the videos in the slides. Why don't you make the announcement, Shannon? Why don't you- So, but the videos will go on to a YouTube part.
What I've done is there's been a couple of requests for the videos, and so there was one person that specifically asked for the last hour of the class.
Okay,
Brooks. Anyway, that's not important, but the easiest way for me to get them to you right now was just to send a link. And I don't think it's accessible through like a .mil address, so.
It's
if
not,
you-
that's right.
Yeah, so it's better if you send me like a personal email, and I'll send you the link to the videos as they come out. You can put them on YouTube too, but that was one step I wasn't gonna take.
okay, so if you're looking for the videos as soon as they're available, send Shannon your personal email address and he'll send them to you.
I promise not to just send you with all.
Okay. Any other announcements?
Sorry.
Sorry, we're rolling. Okay. Let's pick up where we left off without the echo, without the, with the sound back in the room. Hopefully everybody online can hear now. And keep on rolling. All right, product roadmap. So a product roadmap is for a product. And the test question is, your boss comes to you and says, hey, I have to run off to a meeting in like 15 minutes. Can you give me just like a high level overview of where your project is and where it's going and when you expect to reach certain milestones? What document are you going to give them? Well, you're going to give him, and he's like, I need it in like 15 minutes to run off to this meeting. You're going to give him your roadmap, the product roadmap, because that's what it does. It says from start to finish, here's the path we're taking to get there. And at certain markers along the path, we should have achieved this epic or this feature or this phase, this something, whatever you're going to put on there about your project, right? So high level, just generally at this time, you should have this part of it completed. So there'll be road markers along your roadmap. Very simple, high level milestone picture. Okay, so as we're rolling up requirements, let's loop back around to scope. And there's a couple words that have particular meaning for PMI about scope. One is verify scope. And verify scope is where we talk to our stakeholders and we're really saying, is this what you want? Are we on track? Is this the right thing, right? And just verifying, making sure that what I have right now is really what you want. We're good. We're going to ask for their feedback. That's verifying scope. Validating scope. Hold the whole picture up here. Validating scope is where the customer says, this meets acceptance criteria. This meets definition of done. This is what I want. So thank you very much for doing this. I will accept this work that you've been doing. I'll take the product from you. maybe we close the phase or we close the actual project at that point. But validating scope is when the customer accepts the deliverable. This is done. Okay, so we validate at the end. We verify along the way. Am I still within scope? Is this particular work I'm doing in scope? And validate is check mark, we've met scope. I haven't added anything extra in. The picture I created is the picture you wanted. Okay, that's validating scope.
Always at the end, you're saying.
It's at the end. And it might be, it's definitely at the end of the project, but it also may be at the end of a phase.
Sure.
An iteration. Okay, there's the TRANSCOM slide. How do you do all of this? Do you do all of this? You take time to verify scope. I've never worked on a government project that's validated scope. I've never been there to the end. I've never seen a project end. I'm sure some of them have ended. Just in my experience, I have never seen the end of the project there. Odd, actually. I'm sure some of them ended, but oh no, one got killed, dead. Stop, we're not doing it anymore. I did experience that. So, yeah. Okay. Questions about scope. I know it was broken up with a week in between, but what our scope is, how we identify requirements, prioritizing requirements, traditional versus agile. Questions? Questions online? Well, let's move on and talk about schedule then. So here's where we are on the agenda. Why is it important to create a schedule plan, schedule management plan? So what does a schedule management plan do? So it is a document, one of those component plans of a project plan. We're going to define, which we've already done, defined our tasks and activities, but we'll continue to do that throughout the project because more things will become known, right? How are we going to organize our tasks? How are we going to depict our schedule? How are we communicating our schedule? All of those things are going to be in the plan. It's how we're going to manage the schedule that we're going to create. Again, traditional project approach with this. All of the management plans are for a traditional approach. Progress timelines, coordinations we need to do. Just for the exam, the schedule management plan is all about how we're going to manage our schedule and all the pieces of it. And hopefully when we finish this, you're going to be like, oh my goodness, there are a lot of pieces to a schedule. It seems like an easy task, but there's a lot to it. So that's what I want to spend our time talking about. All right, just a couple terms here. Create a schedule. We're going to do a lot of estimating. What our tasks are, how long it's going to take. So what are some estimating techniques that we can use for a schedule? So benchmarking is one. So compare this project with something similar. Took about this much time to do something before, so this is similar or a little bit more. So I'll use this as a benchmark and add a little bit more to it because it's just a little bit more, right? So benchmarking is a good starting point. Pretty quick to do. You already have some data that you can use to compare it to. It's similar. So it's a good way to get started. It's not the most accurate way though, but it's a great way to get started. Historical data is another way. And it's just looking at our lessons learned file. What did we do before? Will that help us get started? Again, both ways are very quick. They're great ways to get started, but they're not very accurate. So it's not what you want to do for your entire schedule. just get you started. So benchmarking historical data. Suddenly I'm like, oh, I don't like the slide.
If you're comparing your current project to something that you've already done, that's historical data, right?
Yeah, so benchmarking is going to use historical data, but historical data may be, we did this event before and we're going to repeat this event. And so we're just use the same
Oh,
timeline. Benchmarking would be something similar.
okay,
So they're both historical data.
okay.
Yes, know what we did. Okay, we have our scope baseline. This is what we're talking about, organizing the task. Okay, so maybe it was the last slide that's out of order. And that's the order it is in your book. Okay. Okay. We have all of our tasks. We have all of our activities. We've got them from our work breakdown structure dictionary, or we've been working on our backlog, breaking things down. But we're going to stick with the traditional approach here. We have our WBS dictionary. We know all of our tasks. Now we're going to start organizing them. One way to organize them is this linear approach, which is sometimes traditional, is called linear. So we have traditional, predictive, waterfall, linear, all means the same thing. So we've identified all of our tasks. This project has 17 tasks. So we start, and right off the bat, day one, we're going to start working on tasks 1, 2, 3, and 4. And then as we move forward, we're going to do all these other tasks. We can see the task 4, 15, 16, 17 relate to each other. Lines of effort, put it in your world, right? We have different lines of effort showing 4 different lines of effort that get us to the finish line. This chart right here is called a network schedule diagram. For the exam, you'll want to know this is called a network schedule diagram. This is a naked chart. We're going to put a bunch of stuff on this chart. As soon as we add more items to this chart, it's no longer a network schedule diagram. I don't know what it is, but it's not a network schedule diagram. Okay, the network schedule diagram is this chart that has nothing but just the task from start to finish, okay? Network schedule diagram.
Supposed to go in order up and down or left or right?
Left to right. So we'll see, we're going to add to this and we'll build to it, but you could put a timeline across the top. And so on July 1st, task 1, 2, 3, and then July 10th, task 11 kicks in, and then July 15th, it looks like task 15, task 8 are rolling. So
it's just a list of tasks and then those tasks are numbered and then you put them in whatever order. Because in my head, I'm thinking it needs to go 1, 2, 3, 4, 5, but I see 1, 2, 3, 4, and then you go up to 5, 6, down to 7. And I feel discombobulated looking at it.
okay. So if we go back to our WBS dictionary and our work packages had 1.1, 1.2, 1.3, it would be very similar to that.
Okay.
So we just have a list of our tasks and we numbered them. If you were going to do this for real in your project, you would probably have the task name up there rather than a number.
Understood. Okay.
We put the name of the task, what you were doing rather than a number.
Okay.
So in this one, very linear. But oftentimes, this is what a schedule network diagram ends up looking like. So we start off line of effort 1, task 1, 5, 6, 7, line of effort 2, task 2, 8, but then 8 feeds in 9 and 13. Task 9 feeds to task 7 and 10. They all start relating to each other. Task 3, 11, 12 relates to 15. Don't know how it relates, but there's a relationship there somehow, right? And so it ends up looking a lot less linear.
Yeah.
So a network schedule diagram is actually really hard to do. So I tried doing one with a very short project, like 12 tasks. I skipped to my Gantt chart. But if you have clearly defined lines of effort, it makes it much easier, right? When you have clearly defined lines of effort, but it doesn't always look as simple as just straight lines going across. But they're both network schedule diagrams. Okay, let's talk about how tasks start to relate to each other. Once we get a logical order of our task, then we're going to start to determine the dependencies amongst our tasks. So there are two types of dependencies. One we call mandatory dependency or hard logic. And you'll see both of those terms on the exam, mandatory and hard logic. And that says that this particular task must come before another task. You have to do task one before you can do task two. Like you have to dig a hole before you plant the flower.
I know I'm looking ahead, but the way you said it confused me a little bit.
Right.
The two types are mandatory hard logic, and the second type you haven't got to yet.
Correct.
Okay.
It's called discretionary. We'll talk about that next. So mandatory, discretionary. Mandatory is you have to do task one before you do task two.
It was just the way that you said it. I feel like there was like, I interpreted a comma after mandatory.
Oh,
So as if
okay,
mandatory and hard logic were the two, but
correct. They're one of the same. Hard logic, mandatory, one of the same. So you just, now, can you plant a flower without digging a hole? I mean, you can think about it as one thing, but for my project, the way I'm managing it is I am telling you, you must do step one before you do step two. So it's a management technique. It's not like it has to be to do that task. But for my project, the way we're managing it, I'm telling you, you have to do step one before you do step two. That's how we're setting up our project, okay? So contract specifies that client approval has to happen at this point in time. You can't move on until you get client approval, or you can't move on until the compliance inspector shows up, checks the box, and then you can move on, right? You're gonna have to,
Aren't those sometimes called gates?
it can be. So gates also help you manage something, and there may be compliance at a gate. There may be something that has to happen before you can move through that gate. Gates are a little bit different than just the mandatory relationship. Okay, so you have to do this before you do another. You have to scrape all the paint before you apply new paint. You have to.
Yeah.
Okay, the second kind is called discretionary, and it's preferred. I prefer that you do step one before you do step two. Okay? That's what we want to do. And so unless there's some reason why we can't, that's what we're going to do. So those are kind of the rules I'm setting for my project. But I prefer step one comes before step two, or task one comes before task two. So we're going to make sure all the plumbing and electrical work is completed before purchasing our appliances. Because our goal is to have a 36-inch refrigerator. But maybe once we get everything in there and framed up and we only end up with a 35-inch space, well, suddenly my 36-inch refrigerator doesn't fit. So I need a 33-inch refrigerator. So if I buy my appliances first, they're sitting there waiting, and then construction gets delayed, and then it gets banged into and dented, and then it ends up not fitting, and now I can't return it, and I have to spend money to buy another refrigerator. And what do I do now with my dented brand new refrigerator? Right? So
Yeah, garage.
yes, hangs out in the garage now. Not a requirement to have a refrigerator in a garage, but boy, did we luck into that one there, right? Lucked right into that. Now I have a refrigerator in the garage. But I've also spent some of my budget that I didn't plan on spending, right? So let's just hold off. Like, you can go buy it now if you want, right? We'll set it over there, but let's just hold off and wait and see if it really does fit. That's what I prefer to do. So that's a discretionary relationship. Dependencies can be internal or external, and that's internal to the team or external to the team. So internal is right, task the team's doing, like team A, finish before team B. And external is activities that go outside the team, like that compliance inspector. That would be external relationship. You have a relationship with something external to the team. So relationships internal to the team, much easier to manage. Relationships that require something external to the team, a little more difficult, right? So I'm buying an investment property. I close August 1st. I called to get, there's a foundation problem with this property. I already know that. So let me get a foundation company out there to look at it. So I built a little Gantt chart. Here's where it is. Shannon, call Foundation Recovery Services. I want an inspection, and let's get an inspection before we close on the house. Because this is the one piece of the budget, not real sure about, so I can start solidifying my budget, go call them. So on August 1st, we can start work. So he calls, and their soonest available date is August 13th. Like, what? So I have this house now I'm gonna have for 13 days that sits there that I can't do anything with, because that has to be the first step, right? So now my schedule's off because it's external. I can't really control that, right? Come back to this. We'll come back to see what Julie has done with her investment property here throughout this little segment. What Julie's trying to do with her investment property. All right. So once a logical order is established and we determine dependencies, we can add dependencies to our chart. So I took off our fourth line of effort just to make more room on this chart, for no other reason, right? But now I see between task 1 and task 5, there's a mandatory relationship. So task 1 has to be completed before I can do task 5. And task 5 has to be completed before we can do task 6. Now, I prefer to do task 6 before task 7. That's our plan. Plan is to do 6 before 7, but it's a discretionary dependency. So if I go to my third line of effort, task 3 has to be done before task 11. Task 11 should be done before task 12. There's some relationship between 11 and 8. There's a line there, but we haven't identified if that's mandatory or discretionary. But let's say it's mandatory. So task 11 has to be done before task 8. Task 2 also has to be done before task 8. So I plan to do task 8 about this particular time, but if there's a delay here, it's not going to get started on time. If it's a delay here, it's not going to get started on time, right? So we're going to add our dependencies to our network schedule diagram, which is no longer now called a network schedule diagram. So mandatory discretionary dependencies. Now, we also have our relationships that PMI sometimes calls dependencies, but think of the term relationship instead of dependencies. So the other one is about mandatory discretionary. This relationship is about how they relate, how this dependency relates. So we have 4 different kinds. The most common, that's a test question, the most common is finish start. When one task finishes, the next task starts. That's the most common type of relationship we see. You're going to finish task 1 and then you can start task 2. Sometimes we have a start-finish relationship. Oh, the first task is called the predecessor task. The second task is called the successor. So within our relationship, the predecessor finishes and then the successor starts. That's finish start. Okay. Start finish, when our predecessor starts, then the successor finishes. An example may be
Your appliances. So if you put the plumbing can't be finished, the connection to your appliance until you've purchased and placed your appliance down. So I've started the appliances, but I can't finish plumbing until the appliances are there.
so many different relationships there. So I finished plumbing up to the point I can. And then you have to So now that I finished, you can buy the appliances. That sounds like finish start to me. Buy the appliances. And now when you install the appliance, then when you move the refrigerator in place, I will finish the hookup for it. Start, finish. Start to move the appliance in there. I'll finish the hookup of the little water line to it. And then we push the refrigerator in place and finish it.
Maybe if in along the same line of construction, but maybe a little cleaner finish start would be something like you can't do the painting until the drywall is done. Like that's like a clear drywall has to be finished.
That would be a start finish.
So that's a finish start.
That's what we were doing, right?
No,
So what is
I-
a start
yeah.
finish? So now let's finish start. That's a good finish start one. Start finish might be, anybody else got an example for start finish? When the speaker starts to come on stage, the music fades out. We finish playing the music when the speaker comes out. Or maybe, the other example was finish start. So when you start user testing, you must stop developing anymore. You got to stop developing and wait for user testing to happen. All right, we're going to start users testing, so you stop developing. So I had a document sent to me from joint staff that said, edit your part. And I felt like my part was so wrong, I couldn't edit. I rewrote it. Like, this is just so off. I'll just rewrote it. So turned a paragraph into a page and a half. I then called a peer at another combatant command and said, hey, this is what I'm going to submit. What do you think? And they said, what version do you have? I'm like, well, they sent it out in our tasker, like version 3. He's like, I'm on version 6. I'm like, how did you get version 6? Well, I called them and they sent it to me. Well, all right, send me version 6. It looks so different, right? So I called the joint staff and I said, hey, I've submitted this, but this one looks different. They're like, well, we're like on version 8. And I'm like, you can't send something to us, like in a tasker to all these combatant commands and say, edit this, and then keep writing it. No, you have to stop. You can't keep writing if you ask us to do edits. So they sent us something. It was really much better. It was good. And I'm like, all right, that's at that point, right? I don't know what to do for you, right? So when you start the process of sending it out to the field for their edits, you have to stop writing. You can't keep writing. Stop and wait for edits. That was nonsense, right? Nonsense. Okay, start. This one's really uncommon. Think of a start relationship. When one task starts, another one has to start at the same time.
say,
That be.
You got when something starts, another one starts.
I mean,
I would say, once I start my plumbing, I also have to start the application to have the inspector come in upon done. So we knew the inspector's gonna take 14 days before they come. It's gonna take 14 days to do the electrical. So when I start electrical, I put the application in for the inspector to come.
Go ahead. As soon as you start this, it's going to take them a while to come out. So go ahead. Contact and schedule the inspection as soon as you start the task. Start. 2 different tasks, right? Schedule the inspection, start the work, start relationship.
So they're not necessarily, it's not necessarily that one has to, you have to start both at the same time, but you can,
So
it's preferred.
it depends. Is the dependency mandatory or discretionary? If it's mandatory, you must start them at the same time. If it's discretionary, then it's preferred that they start at the same time.
Like in that example, that would be discretionary because it'd be ideal to have the plumbing inspected as soon as possible.
No, it could be both.
Right.
You still can be both mandatory or discretionary. If my project has to be done at this date,
Sure.
right, then I have to start the inspection process in order to meet that date.
Right.
So it could be mandatory or discretionary.
Start
Be what the
the.
project manager or the team decided.
Sure.
Right? So it's
Fair
a way to manage and create a schedule then. Okay, start. Finish. Who's got a good example of finish?
I mean, so for another example for start might be something like we have our uncleared contractors coming in to do this renovation project, and now we have to relocate a classified team to another location. So that's like, they're very related, but when this project starts, this other thing is happening. And then finish could be, now that this project is finished, this relocation project can also finish.
So we want to say that there is a relationship between them. So ideally, the way I'm going to schedule my task and manage my task, I'm going to say they have a finish relationship. So I want them to finish at the same time. So it might be two teams working separately related to a project that need to be finished at the same time. That's the plan anyway, is that they'll finish at the same time. So maybe we're building a bridge and one team starts on the west side and one team starts on the east side and we're going to meet somewhere. Let's hope not, but maybe, right? And so ideally, we've planned a schedule where they're finishing at the same time. You know, my best example for finish is cooking dinner. I want everything hot to be done at the same time. So I'm starting them at different times so they all finish at the same time so that everything is hot is coming out together hot. Now, don't put cooking dinner on your PMP application. It's your project here, right? But that's the finish relationship. You know, I have things planned of when I start cooking them based upon when they're going to finish so that they all finish at the same time. Finish relationship. Okay, a couple more terms. Any questions online? All right. Couple more terms. Duration, simply the time it takes to do a task, right? Pretty common
Question.
word. Yes, sir.
Question is it a must finish?
Yeah, so in the relationships, whether it's any of those four, finish, start, finish, start, finish. If you say that the dependency is mandatory, then it's a must. You've made it a must as the project manager. If you say it's discretionary, then that's preferred that happens. Right? So you get to decide whether it's a must or not as the project manager. But you want to decide because it affects the schedule. Right? It affects the schedule. So if they must finish at the same time and one takes 12 days and one takes 4 days, well, I know how to schedule them. Because they have to finish at the same time, right? Even to start at the same time or whatever. You decide whether it's mandatory or discretionary. Okay, some vocabulary that relates to scheduling. Duration is just how long it takes to do something. What's the duration? Is how long? The elapsed time is the time from start to wherever we are now. How much time has elapsed? How much time have we already spent? That's the elapsed time from start to wherever it is now. How much has elapsed? And then milestones do not have durations. Milestones is just a mark on the calendar. It's just a point in time that something's going to happen. So either it's a gate that we're going to cross through, or it's the inspection, but it's this goal I'm shooting for on this date, something's going to happen. Right? That's a milestone. So milestones do not have durations, just a point in time on a calendar. Tasks have durations. Takes time to do task, they have durations. And your duration can be any unit of measurement you want to use to manage a project. Hours, days, months, years, calendar years, fiscal years, it's whatever you want to use, but keep it consistent throughout your project. So sometimes we start managing a project by years, and as we get down closer to like an event happening, we'll start shifting time. But you want to keep it consistent. When you change from months to days, because now we're down to the last month. So the last month, we're going to shift down to 30 days. But we're not gonna do some days, manage it by days at some point, manage it by months by others, and then back to days again. You want to keep it consistent. It's really confusing to a team to not have it consistent. Okay. Let's now talk about estimating. We did benchmarking right up front as just getting started, but there's much better ways to estimate. This is what we want to talk about. Analogous says, it's an analogy. This project is like that project. That project took about this much time. This project should take about this much time. Or that task took about this much time before we did it. So we're going to say it's going to take about this much time again. So that's analogous. It's a guess. It's an easy way to guess. Estimating is all guessing. So it's an easy way to guess. It's quick. It's just not very accurate. So on the exam, you're going to be asked the least accurate way of estimating, and you're going to say analogous. It's the least accurate. Maybe your personal experience. Good, just the least accurate. Parametric. Parametric is you putting a lot of information into a computer and the computer spitting out the answer for you. The computer is going to crunch some numbers and spit out durations for probably several things at once. So for the exam, what you want to know about parametric is that you're going to use a computer. You're going to tell it a bunch of information about the task. It's going to put them all in a line for you, put them on a calendar. It'll tell you about how long things will take based upon whatever factors you've told it to calculate. You may say, I have a team of new people, and the computer's going to go, well, that's going to take longer to do then. Or I have a team of experts. Well, then you should be able to make it happen quicker.
Is it common for project management software that has these type of calculations? Is that a common?
Yeah, project management software will help do a lot of scheduling, but it only knows what you tell it. So you have to input a lot of information into it.
That is always good.
Yeah. It's a really good way of depicting the results of what you've told it.
Sure.
Yeah. Okay, let's get 3-point estimating because I want to talk about that in more detail. So let's talk bottom up first, and then we'll get the 3-point estimating. Bottom up estimating is the most accurate way of estimating. You'll want to know that for the exam and in real life. It's the most accurate way of estimating. Bottom up estimating is looking at your work breakdown schedule, looking at all the tasks and activities that are part of your project. And then you're simply going to say, well, how long does it take to do this task? How long does it take to do this task? How long does it take to do this activity? And you add it all up. And it gives you overall, my project to do all of these tasks and activities should take this much time. So that's bottom up estimating. You're looking at each individual task. The most accurate takes a long time though. So if you have 100 work packages and each one of those have just 5 or 6 tasks, 40, we're spending a lot of time estimating. It takes a while, but it's the most accurate. Okay, let me get back to 3-point estimating now. 3-point estimating is where we're going to take 3 units of time and basically average them. We're going to say, what is our most optimistic estimate? What's our most likely estimate? And what's the pessimist? So what's the shortest amount of time it would take is optimistic. What's the longest I think this could take? That's pessimistic. And what's most likely? What do I think is most likely based upon my team, my experience, other things going on, right? What's most likely? So we take those 3 factors and we basically average them. So if we take those 3, optimistic, most likely, pessimistic, we call that triangular distribution. You just take optimistically, it's going to take me 4 days to do this. Most likely, 7 days. Pessimistic, I have to add 13 days for an inspection now. I have to, man, so pessimistic, it could take 22 days to do this if things don't happen right. So I have 4, 7, 22. I add them together, divide by 3, it gives me the average, and that's what I would use for my duration. We call that triangular distribution. Okay. On the exam, people who have taken it recently said there's no calculations on the exam. But this is one where there was a calculation. And I do know that although people have said there's no calculations, they've come across these where they've had to choose the right number. But the numbers they give you are so easy, they don't feel like calculations. So they haven't had to use the calculator on the exam. But this is a formula that I'm pretty sure you need to know for the exam. Okay? Triangular distribution is simply optimistic, most likely, pessimistic divided by 3. The other 3-point estimating technique we call beta distribution or PERT distribution. Beta or PERT. And beta or PERT says, well, if most likely is most likely, let's weight it so that it is most likely. So we put most likely into our formula 4 times. So now we actually have 6 elements to consider, not just 3. So we're going to average 6. So we have our optimistic plus 4 times most likely plus our pessimistic. So 6. So the formula looks like that just flashed on the screen. Right. So beta or PERT distribution, you'll see both of those on the exam. Beta or PERT weights most likely by 4. Why by 4? I don't know.
Yeah, that's interesting. I feel like if most likely is most likely by a hair margin, I don't know if times 4 is correct. Like,
So it's not.
Yeah.
So then you get to, if you're like, no, really, or so many things keep going wrong, that pessimistic really keeps coming up, that I'm going to weight pessimistic. That says something about you. We're going to talk to you some more, make you a little happier maybe. But so beta or PERT says 4 times more likely.
And will we need to, for the exam, we would need to know that formula to know the 4 times?
Correct.
Okay.
Correct. Divided by 6.
Right.
Right.
Right. Still finding the average, but we have to remember beta PERT distribution 4 times the most likely.
Correct.
Okay.
And in real life, if you wanted to do something different, there's nothing that says you can't. You know your team, you know your situation, you know the project. You're figuring out schedules and durations. You want to adjust it some, go ahead. But here's the PMI book formulas for you. So if we look at this, let's figure some out. Optimistic is 8. Most likely is 14, pessimistic 26. So these are days, hours, months. We'll say days.
8 divided by 3 is 16.
Fast.
Boom.
Boom, our math was it here. 16, triangular distribution. Everybody else gets 16 for triangular distribution?
Sure.
On the exam, it'll all be, it's a very trusting group. There'll be round numbers. There won't be fractions. The numbers will come out to whole numbers, so you won't ever have to guess, figure out how to round up or round down. So 22, 48 divided by 3, 16. Everybody else got 16? 16 for triangular distribution. How about PERT distribution?
16, 40, 66, 20.
Anybody online figured it out? Put the answer in the chat.
70. Oh, that's 100? No, that can't be right.
90 divided by 6.
There we go.
15.
That's it.
15. Yeah.
15.
Well, I failed.
Did anybody online get something different than 15? So if we were going to do our schedule for this particular task, if we were doing triangular distribution, we would give it 16 days to do the task. If we were doing PERT or beta distribution, we would give it 15 days to do the task. But you think hours, days, not so bad. If you're doing months, now that starts to get significant. Okay, so now we're going to go back to our diagram and we're going to add in our durations. So we have task 1 is a duration of 12 days. Mandatory, we get to task 5 is 5 days. And then mandatory, we get to task 6 is 3 days. And then 7. So we add our durations and we're filling out our charts some more.
So do you ever like pad any of the times? Because, I mean, especially where we work, right? Like no one is ever working on one project. There's a lot of external factors, so that could delay it or whatnot. So do you ever add more time or go with this most pessimistic? So when you actually deliver on the most pessimistic, it's not.
I think the better question is, can you combine estimating techniques? So I'm going to start with 3-point estimating as my starting point, and then throw in analogous, like what I know, or historical data. Historical data, it starts raining a lot this time of year, and when it rains, we lose productivity. Can't work outside as much. We're coming into summertime and people start taking vacation, and we're not as productive during this time. PCS season, a lot of turnover happening with personnel, so it slows down the work, right? So then this is where we get smart as managers, go, okay, so this is what the formula says, but I know this time of year, we're about 80% productive. So I need to add another 20% onto the time. Absolutely. We start to know our team in the same way. I know this is what the book says this, but my team is really fast, or I have a lot of new people on my team. So I'm just, turnover season comes, PCS season comes, I got to slow it down. I got to add more time into the schedule to take us longer because, you know, they're taking time off to get their household goods, that kind of thing.
Yeah, and you may have mentioned this, but I may have missed it, but why would you use one over the other on the triangular versus the beta and the perp one? Like, is that just your, going with your gut there and, picking it, or is it, I guess it's, why not just go with triangular all the time, or why not just go with beta all the time?
So sometimes there's a big gap between optimistic and pessimistic. And sometimes like pessimistic rarely happens. And so why do I want that to be a factor? Right? I really am trying to make the best schedule I can get. So I really want to do most likely. And I have enough experience to know what's most likely. So if I don't have a lot of experience with this, we don't know, I would just do triangular distribution and let them all weight equally. But it really does. Most likely probably is most likely, maybe a little factor. So it really is your preference.
Okay. In theory, the PERT distribution is more accurate. If you're saying that optimistic and pessimistic are outliers and you're weighting them the same as most likely, in the PERT or the beta distribution, you correct for those statistical anomalies by providing heavier weighting on the most likely, which would be what we call your statistical norm, your middle of the curve, right? If you're looking at a parabolic curve. So in theory, PERT is more accurate.
In theory, PERT should be more accurate. Yes. But if we could calculate everything with just numbers, right?
Yeah.
You wouldn't need the manager in there. It really takes, some thinking from the manager to work this out. Okay, a couple more terms before we move on with more scheduling to our next break. Sometimes tasks occur simultaneously, and we call that lead time. That overlap between the two tasks, we say is a lead. It's the overlap. So although task 1 takes 15 days and task 2 takes 12 days, that's a total of 27, but I don't need 27 days to do it because they can overlap by 3 days. So I only need 24 days to take these two tasks that by duration look like it's 27, but they'll overlap. So that's the lead. Their second task has a lead on the first one. The other term is called a lag, where one task has to lag behind the other. So there's a wait period that has to happen in between. If you're going to build a schedule, you have to account for your wait period. So we're going to pour concrete, and then we have to wait for it to dry and harden before we can start putting up the walls. We're going to paint, and then we have to wait for the paint to dry before we can hang the pictures or the monitors or whatever we're putting on the wall. Right? So that we have a lag. So that wait period in between is called lag. Okay. been rolling for 50 minutes. Do you need a break? Is this a place for a break? Roll a little bit more? Okay, I'm gonna throw the, hopefully it's not confusing, not you. All right, before we go on break. All right, so now we have our task, we have our durations, we have the relationships we know about leads and lags. We're going to determine how long, at least how long it's going to take for our project to happen. Like how much time do we need considering leads, lags, durations, all these things we talked about. So we call that the critical path method. And the critical path is the longest path that we have because we know our project cannot be completed in any less time than the longest path. So we're going to start at the start block and we're going to count over our paths to see which one is the longest. So how many paths do we have? 3. Dark blue, light blue, and orange. Plus we have light blue, task 2, light blue, task 8, light blue, task 9, dark blue, 7, down to finish. That's a path.
Right.
And we have a path of the bottom, orange 3, orange 11, up to 8, over to 9, to 7, or to 10 and back. And then we have from 3 to 11 to 8, down to 13, over to 14. How many paths do we really have? We have 7 different paths in this chart with the combinations. Just whether they're,
Dependent.
yeah, discretionary or mandatory dependencies.
So you do factor in the discretionaries when you're doing critical path method?
If we're just gonna factor critical path, we're gonna look at duration.
Okay.
Just duration for now. We put in our duration, giving ourselves a little wiggle room in there. So we have our duration. Where's our longest path? For those online, just put in the chat what you've counted for the longest path.
Ugh. Okay.
Just one answer on this one. In real life, you may have 2 paths that are equally long.
Okay.
So I guess what I'm getting, do we say it?
Sure.
I think it's 48 and it's task 7 to finish. Because they're all tasks, the middle task leads up to task 7. So you've got all of that time.
So task 2, 8,
Or I guess
9,
we're not
7
adding,
is the path?
Yeah, we're adding up.
Yeah, so
Oh.
you want to add them up here.
but you're
So-
not, but task 1 would be happening simultaneously though, right?
Right.
Okay, so I'm wrong. I did the math wrong because I wasn't thinking of I was thinking total time to get to task 7, but
Mm.
there's
So we want to
simultaneous.
finish.
I think you were close though, because I'm still seeing, just looking at it, task 2 to task 8 to task 9 is more than the sum totals of task 3 to task 13, right? And then to task 7 to finish.
2897 is the most by one. day.
Yeah,
Which
Yeah, I
one
think
is
we're
the
all-
most?
2897 by one day.
Or one day, yeah.
2, 8, 9, 7 is the path. So if we add up 2, 8, 9, 7, we have 6 days plus task 8 is 6 is 12, plus 9 is 21, and 7 is 7 more. That's odd that they're the same. 28 days for the path that goes 2, 8, 9, 7 to finish. So we have a dark blue in the task. So task 1 is 12, plus 5 is 17, plus 3 is 20, plus 7 for task 7 is 27. So that path is 27. That's almost as close. We go to the bottom, the orange path is 2, 4, 6, 11, 12, 13. That's a pretty short path there.
Yeah.
So we're going to add all of the paths up to find the longest.
Right.
For the exam, the hardest part of this is remembering what path you took.
Yeah.
Right? As you found out here, looking at him, you're like, oh. So, but the critical path is 2, 8, 9, 7. It's the longest path. 28 days for the longest path.
So would the exam, I'm trying to think of how you would articulate the path on the exam. That would be one of the multiple choice questions is 2, 8, 9, 7 is the critical path of 28.
Or would it just be 28?
Right.
Is the answer we're trying to find 28?
Yeah, so it'll ask for the critical path and give you,
Doesn't matter what path you took.
questions now, but it's gonna ask, one's gonna ask you what the critical path method is. So you're counting out to find the longest path. You're probably doing critical path method. Sometimes it says critical path method where you think that doesn't make sense, but if it should say the critical path rather than critical path method. So it'll, again, some of the questions aren't worded the best. There's a question that says critical path method that just read as critical path. Fine. But yeah, it'll ask you to determine the critical path and it may lay out paths. It may just ask for a number. Yeah, it may ask for a number. I remember counting out paths.
Yeah.
Drawing on my little whiteboard, the diagram to remember what path I had counted and not.
So
Okay, so the critical path is the longest.
I'm not saying this is longer, but is task 3, 11, 8, 13, 14 a task? Or
It is a
how would
task.
that even work?
It is a path. So task 3 is 2 days, 11 is 2 is 4. We go up to 6 is 10. I mean, task 8 is 6 days is 10. And then one of the path comes down to 13. So that's 5 more days is 15. And then over to task 14 for 2 more days is 17.
Does
That is a
task
path.
12 play into that? Because task 12 does seem like it needs to, I know there's like some simultaneous stuff happening here, but I'm just trying to figure out. Like,
You're doing task 12 while you do task 8.
yeah, I'm just trying to figure out how to, it just seems weird to me that I could even say 3, 11, 8, 13. If for instance, task 12 was 20 hours, right?
Mhm.
I can't say that the task to finish is only 15 hours when I just skipped it through a path when it's a mandatory a mandatory step.
It's a
So-
mandatory dependency with 13.
But that's what
It's not a
the
path to
path that
completion.
counts
It's a
different.
timeline.
Wait,
for
you don't know,
tasks.
what you don't know, what you don't know here is it start to start, finish to finish, you don't know that dependency. Maybe in that arrow, usually when you do the arrow, you do it a certain way, so you know the dependency, like.
So
I think what Olivia said makes sense to me, which is basically it doesn't actually matter what the second longest path is. And so if there is a path that has a 20-hour task in it, then that might make it the longest path. And it doesn't matter if I can build a path that's task 3, 11, 8, 13, 14, because we don't care about that one if there's another path that is longer.
What we're basically finding is the minimum timeline for the project.
Yeah.
So to complete this project, the critical path is 28 days. Well, you can't take 25 days. It has to take at least.
Right.
it's going to take at least 28 days to do it.
Yeah.
Now,
Minimum time.
it's like, wait, but wait, because this has to be done before here. So 12 has to be done before 13, and we're skipping it when we jump up to 8 and back down.
Yeah.
Oh,
But that's okay if we skip it because there's going to be time for it to happen.
Right.
Because this path takes less time than the critical path.
It would be a lead time
We're going to talk about float.
project.
And that's what you're talking about. So we got to make sure, because this is a mandatory relationship, that this relationship has to happen. So when we schedule this task, knowing it's not on the critical path, that tells us we have some room.
The critical path isn't like project completion. It's time to completion.
So the dependencies will work itself out. The critical path just tells us we need at least this much time to do this project. This is the quickest we'll be able to do this project. We're going to work out the dependencies when we actually schedule the task. But what we know is right now, this project is going to take at least 28 days. Well, you know what? It has to be done in 15 days. Well, we're not doing all of these tasks like this. It's not going to happen.
Yeah.
It's not going to happen if you need it in 15 days. It's going to take us at least 28 days to do it.
Chili has a question in the chat. The dotted, is it discretionary? It's confusing. So we're only including the mandatory. That's to clarify.
Yeah, that's what I was hoping to be answering right there. The dependencies will work itself out when we schedule it. So we know that there's a mandatory dependency between task 12 and 13. So task 12 takes 2 days to do. So it has to start at least 2 days before task 13, just 5 days. Now, when can that happen? Because it's going to happen within 28 days somewhere. And if finish is day 28, then I'm going to back off task 14 is 2 days. So it can finish on the 28th and it has to start on the 27th then to give me 2 days to do it.
Right.
So on day 27, I have to be doing task 14. So let me back that up 5 more days to do task 13. But that's a discretionary dependency. So I might be able to play with that a little bit here, but I'm going to back up 5 more days. So day 26, 25, 24, 23, day 22 is when this one will start. Task 13 will start on day 22. And then let me back up 2 more days. So day 21 and day 20. Because this task 12 is a mandatory relationship with 13, it really has to start on day 20, or we've just screwed up the rest of the task following on down the line here. And that's called free float. We'll get to that in just a little bit. But so that's how the dependencies work in on when I'm actually scheduling the tasks.
But for determining the CPM, the critical path, you can still factor in your discretionaries as part of your path.
It doesn't matter.
It doesn't.
It won't affect it. The only
Exactly.
thing in determining the critical path is the duration.
Got it.
So
Got it.
what's the longest duration?
Yep.
And the dependencies will come when we schedule the individual tasks.
That
We
makes
were
sense.
going to do them. But right now, we know that we need at least 28 days.
So in finding out your critical path, you're not necessarily looking at the timelines, right? But you're not looking, the only relationships you're looking for are the mandatory relationships to get to the end. Because that line with the longest duration has all mandatory requirements.
It just happens to have mandatory ones.
Yeah, it's not saying you have to use mandatory.
So it just happens to be that way. There could be discretionary ones.
This is all presumptive on the idea that your tasks are well-defined prior to starting,
Which is traditional.
which is very traditional, but also, I mean, there's mission creep in every task, and we know that. I mean, even the most well-defined task is not exactly defined to a science.
Bobby, you must be listening.
So, no, I work with manpower. That's what it is. So, like, when you go in there and it's about understanding the body of work or the work requirements, right? The KSAs and all the things that you have to do to complete, the mission, a task and a mission with whatever. But the thing is, for me, you can believe it's 6 days all you want, but maybe 7. And that's where you start sliding the schedules left and right a little bit, right? So maybe 7, maybe 5, you don't know.
Slide our schedule.
Take 6 days.
Ideally, what we want to do is say,
Yeah, or that.
you know what? We know this always ends up moving. It always ends up taking longer than we want. So we want to factor that in when we're calculating durations rather than just shifting our schedule. So when we know that from our own experience, that's the analogous estimating, we're going to combine that with the triangular distribution. So triangular distribution gives us a number, but we know we always need 20% more time, 30%. So let's factor that in at the duration to determine our critical path rather than making us change our schedule. Because we're going to create a baseline. And so this is going to create our baseline. 28 days will be our baseline. So when someone says, how are you doing? You're going to compare your current progress to your baseline. And if you don't factor those in on your baseline, then you're just always going to be behind schedule, shifting to the right. Project manager, you can't ever keep a schedule. No, you don't want to be that project manager. So you're smarter than that. So I'm going to consider all those factors in the duration. And so my durations become more realistic. And now my schedule should be more realistic. Now, everything goes well and you don't actually need that time and your project finishes early. Like when you give a report, don't you really want to say that you're ahead of schedule rather than behind schedule? So I'm not saying that you want to like just add time into your duration to make it look good. You want it to be realistic. But when you know that it just takes longer, we just know that it always happens. Especially with manpower, you're always dealing with people. And that always has a large degree of unpredictability. So just build that into the duration part.
I would suggest it's very much a DoD way of thinking and not a corporate way of thinking, because so you can pad the budget a little bit, right? We all know that, padding the budget up, the time budget here, right? So the 20% or the 30%. But at some point in a corporate model, there is a deliverable and there is a hard deadline where, you will be measured like, okay, if you go over 20% long, then okay, you're still within the limits. But if you're 21% over, then you failed and now you're subject to termination or to, bad reviews, bad performance reports, right? So there is a performance metric that I don't think the DoD inside all the projects that I've ever worked on, like, whatever, we're, pad the budget and we're still going long. Because what ends up happening is we add the time in and now people react to the extra time.
So I worked full-time for the government and then I left and I went to private industry. It was only then that I realized, without even knowing it, when I worked for the government, I just planned to have things left over to do the next day. Corporate, it didn't work that way. I was measured every day. I got a report card on how I did the day before. And I realized then that I'm like, oh, yeah, it's not things planned to the next day. And in fact, every decision I make today is affecting how it ends up today. That affects my numbers tomorrow I get. Like tomorrow's numbers, I can't change. The numbers they give me tomorrow about today, I can't change. So I started every 15 minutes, I could run a report to tell me how I was doing with labor, with cost, different inventory costs I had. And so I didn't always run 15 minutes, but there were some days where I'm like, because of whatever, we're super busy or super slow, I got to know where I am because I have to make some decisions right now if I want those numbers to come out. I never had to worry about that in the government. Like whatever, we're rolling, right? So in a way, what you're saying is right.
Yep, that's exactly what I'm saying.
But be a good project manager, regardless of who you work for. Why aren't we being good project managers for the government? Should be, right? So you make your durations realistic. And if that includes understanding how the team works, that we always end up needing more, we factor that into duration so then we can make a good schedule. You want your estimates to be as accurate as you can be. And because none of us have a crystal ball to see the future and know what's going to happen, right? None of us come to work 100% ready all the time. And, right? It's a human factor in there. So you make your durations as realistic as you can. And then the critical path doesn't account for any dependencies. It's just the longest path on your the schedule network diagram. The longest path. So that's the least amount of time it's going to take to do your path. Good? 10-minute break?
I've got another question.
Take a 12-minute break. Another question? Oh, up there? Ooh. Yeah, so you don't account for that on your path. That's like, I plan to have an inspection done on the house before I close, and now I find out that 3 weeks before I can even get that initial inspection, and how much longer before I can get the work done, right? I can't account for that. That's one of those things that now I'm going to adjust for, and we'll talk about some topics of when we get some techniques. So if we get off schedule, how do we get back on schedule again? There are definitely things that will throw you off schedule. And if it's within your own team, you have control over that. But if it's outside, you don't have control over that. Those things are going to happen.
So, and along with external, I mean, how do you account for if you're not even in charge of the duration? It's, you know, some two-star somewhere saying, I want this in 10 days. Does this kind of go out the window then?
You know, it takes so much time to do something and it just takes that much time to do something.
Go
So
back,
take
get it
these
back.
15
You
hours.
create
Yeah,
this.
what was that triangle we had last week? It was like, it was
That's why
Quality
a
with-
triple constraint triangle. We're gonna mess with our schedule. It's going to affect budget or scope. So if you need it in this much time, I either have to do less, or get more people to spend. And we call that crashing. We'll talk about those terms coming up here. Yeah, so if you need it shorter. So I learned at Uncommon, we could do anything with more time and more money. Give me more time and more money, I'll make anything happen for you, right? I don't. I mean, that's just the first place I heard it at Uncommon, I guess. It's common out there for everybody. All right, so critical path, the longest path.
Yeah, A1.
That's the shortest amount of time you can do your project. Okay, did that answer your question, Paul? You really can't account for it. All you can do is make up for it. Or fall behind schedule. That's what the choice is. Okay, let's take a 10-minute break. We'll come back at 25 till and then roll up through lunch. All right, we're gonna get started again as soon as we have audio that's ready to roll.
I just happen to be in the.
Loading.
I happen to drive.
Well, this is the longest discussion I've ever had about the critical path method, so I really appreciate the questions and the discussion.
Okay, you're good.
All right, so now that we know a bit about the critical path method, let me show you what you're likely to see on the exam for those who want to take it on the exam, those who want to take the exam. So this is their version of a scheduled network diagram with other information. As soon as I tell you how to read it, you're going to be like, oh, well, this isn't a problem. I don't know.
Do they give you the key?
My name is on the bottom down there.
Is the key on the test or we gotta know
It's
it's
on the test.
right?
Key will be on the test for you. Okay, so every time they show you something like this, they'll give you a key. Let me tell you how to read this key. In the middle, the A, B, C, D, that's the task. That's the activity. It's the actual thing you're going to do. This number in the top left, ES, is early start. So that's the early date that this task starts. The bottom, LS, is late start. So that's the latest this task could start. The top right, EF, is early finish. And the bottom is late finish. When you could start the earliest you could start the task and the latest you can start the task. The DUR that's in the box is actually the number above the box. That's the duration. So for activity A, the duration is 3. Activity Charlie, the duration is 2. Okay. And then the FLT at the bottom is float, and float's not on here. There are no numbers for float on this chart. And generally, what you'll see on the exam won't have numbers for float. It may ask you to determine float. We'll talk about that in a bit. So this is the type of diagram that you'll see on the test for calculating critical path.
Do you only use the total number at the top for calculating it?
Yes, the duration.
The duration.
They'll use the duration, and that's the number that's just above the box to calculate critical path.
Yeah, that's way easier than trying to calculate. Okay.
When we started, the way we calculated critical path, we went to start and we added up all the different possible paths.
Yep.
And moved across our chart to the finish or the end. That's called a forward pass. So forward pass from left to right, start to finish. If we were going to calculate backwards, like I did counting backwards when things needed to start, starting at the finish line and counting backwards to start is called a backward pass. Okay, so forward pass going from start to end, backward pass from end to start. We're going to come back. I'm going to come back to that as soon as I introduce this concept of float. Because we plan a schedule, the critical path, but sometimes we float. And this is what float is. 2 types of float, total float and free float. It's very possible to have different numbers for total float and free float. Actually, a test question. They're not. PMI says they're not connected. They kind of are connected, but they're not connected. Therefore, they can have very different numbers. Total float is the amount of time, the maximum amount of time that an activity can be delayed without affecting the total project. So total float is the amount of time that an activity can be delayed before the total project is delayed. So if you put total in before project, total float's easier to remember that way. Free float is the amount of time a task can be delayed before it affects the next one in line in its path. Now, the definition says any of its successors, but it's that next one. It ripples down. Okay, so free float, the amount of time an activity, a task can be delayed before it affects next in line. is free float. Okay. Total float and free float are part of the critical path method. And it's how much wiggle room you have within the task, how much flexibility you have for each task. Okay. We throw out a brainy question. And I don't know why, because on your slide, it gives you the answer right afterwards. But when does float equals 0?
Critical path.
When it's on the critical path, there is no flexibility. You have no wiggle room on the critical path. Right? So there's no float on the critical path. That's what the critical path is. It's the least amount of time to do a project. It's going to take at least this much time to do this project. There's no wiggle room on the critical path. So it's only those tasks that are not on the critical path that have float. Okay? So on the critical path, no float. There's at least 2 questions on the test about that. No float on the critical path. Okay. Back to this chart. Forward pass, going to the end, backward pass from end to start. So let's look at the end. And our red path is the critical path. So that's, it's going to take at least this much time to do this project. So if it's on the critical path, there's no float. I know there's no float on this task because my top numbers and my bottom numbers are the same. My early finish or early start and my late finish, late start, late finish, late start are the same. So I know there's no float there. I'm going to tell you when it asks you to calculate float, I'm going to tell you the shortcut when you see this, okay? This top chart, the difference between the top and the bottom, doesn't matter if you use start or finish, you're going to see a difference of 1. It tells me that this task activity Foxtrot has 1 day of float. Because there's a difference of 1 between my late finish, early finish, and late finish. If I go to activity Charlie, I can see the difference between the 5 and 8 or the 4 and 7 is 3. Then I know that task has 3 days of float, which means right now it's scheduled to start on day 4, my early start, day 4. So it follows activity A. Activity A starts on day 1. It takes 3 days, 1, 2, 3. So I'm going to start activity Charlie on day 4. But because it has 3 days of float, if I don't start it on day 4, I could start it on day 5 or day 6, and I'm still going to be okay. It's not going to delay my project. I will still be able to finish my project on time. If I can't start activity Charlie until actually my late start, 3 days, so it starts the following day, it's 7. My chart tells me that I can start activity Charlie on day 7, and it's not going to mess up my project.
Your total flow.
This is going to be total float.
Right. But you have to start on day 6 for Charlie in order not to affect the free flow. Or rather, I guess.
We're going to calculate float doing a backward pass for float.
Oh, okay.
We're going to do a backward pass to calculate float. So my critical path method says I need 11 days to do this particular project. So the 11 is above the end. So I know it's 11 days. So task Foxtrot is 3 days. So day 11, day 10, and day 9. I need to start. My late start is day 9. Right? And then let me back up to Charlie, takes 2 more days. So that's day 8 and day 7. So my late start is day 7. And then let me back that up to activity A, which is 3, but I can't do that because it's on the critical path. So that path from Foxtrot to Charlie to Alpha, but Alpha's on the critical path. So I'm not calculating float backwards there. It has no float because it's on the critical path. Okay, so the shortcut for know what total float is, know what free float is, those definitions. If you're to calculate float, you do a backward pass. It's just as simple as counting back the days. It's not as simple as subtraction because you get a work day in there, so it's easier to count and say the numbers. For me, it's easier to count and say the numbers. You do a backward pass to calculate float.
So sorry, F was 8 or 7?
So
Doing a backward pass.
doing a backward pass on day 11 is when we end. So we
Right.
could end on day 11.
Right.
Latest finished is day 11.
Oh, I see.
So it would be 11, 10, and 9 would be, so it's 3 days, but it counts.
The end day.
It's not just a subtraction because it actually counts.
That's what confused me as I was doing the
Yeah.
subtraction. I'm like, where's that extra day?
Yeah, that's, you have to back. But if we were doing a forward pass to get to Foxtrot, we would say Alpha is 3 days, plus Charlie is 2 more days is 5, plus Foxtrot is 3 days, takes 3 days. So I have to figure out all of the paths to know the earliest it can start. So we have mandatory and discretionary dependencies, right? This is where you have to calculate mandatory and discretionary dependencies or mandatory dependencies. We've just done durations, but if we're going to back them up and move.
So even though you finish Charlie at day 5, Foxtrot can only start at 8, and that's why you get to 11.
Correct.
Okay.
So my early.
So there's a float between Charlie and Foxtrot.
Earliest that Foxtrot can start is day 8 because of the tasks that come before it, because 4 comes before it as well.
Right.
So I would have to look at this path. So going backwards, right? I went up to Charlie. So from Foxtrot, if I went to Delta, that's 4.
Yeah.
Right, so I get early and late start dates because of the other paths that it's on. It's on 2 paths. Okay.
So if you have like 7 or 8 paths, that thing can be kind of fun to,
Whoa, if that one's on like 7 paths,
yeah,
you're counting all of them to do a backward pass to figure out floats.
somebody should make some software to do
But if you get to the point where it's like 1,
Yeah.
don't count the other paths. You got 1 day of float, that's it. Don't even count the others. That's it. It's no shorter than 1.
We're still a little confused online, so if you want to.
Yeah.
Us.
It's because I keep saying this and they don't know what I'm pointing to. So, okay. Backward pass from end to start. We're good there, right? Online. And then, so I know my critical path is the red path, float of 0. No wiggle room on the critical path. So counting backwards, if I went Foxtrot, they've already figured it out for me. The earliest I can start is on day 8 because of the other tasks that come before it. But I could start as late as day 9. My late start in the bottom left, I could start as late as day 9 and I'm still going to be okay. I may finish day 10 if everything goes right, but if not, I'll finish on day 11. That's what the boxes say. So counting backwards from end to go to, so my task activity E is on the critical path, so that's 0. So I'm not even going to figure that out. It's 0. So Foxtrot, though, takes 3 days. So don't just simply subtract 3 because you can do on the 11th. You can work on the 11th. So day 11, day 10, day 9 tells me that that's the latest I can start Foxtrot is on day 9. Or I'm going to delay my project. If I don't start by day 9, I'm delaying my project. And then if I go to task Delta, it's 4 days. So I'm going to back that up, day 9, day 8, day 7, day 6. So 4 could be 6, except nope, something else is affecting it. It's on the critical path. So it's being affected by another path. So I'm figuring out the critical path first, right? And then I'm figuring out my float. How much wiggle room do I have for my other task, not on the critical path? So from Foxtrot, I can go to Charlie. So let's say my early start date, the latest I can start is day 9, doing a backward pass. So what's the latest I can do Charlie? It takes 2 more days. So that's 8 and 7, day 8 and day 7. So I end up with day 7 for Charlie. So although I have 1 day of float for activity Foxtrot, I have 3 days of float for activity Charlie. Now, activity Charlie gets behind 4 days. More than my 3 days of float. What did I do? I just stole my day of float from Foxtrot. I borrowed that day of float. You would now have 0 days of float up here for Foxtrot.
Sure.
Does that make sense?
Mhm.
Did I confuse online even more?
I mean, this is already filled out, so you could just subtract, define your, I guess that would be the free floats. You could subtract the left 2 columns for each of those on the non-critical.
On the exam, it's going to ask you for float, and I believe it's going to, thank you. I believe it's going to give you all of this, and all I do, I want you to subtract the numbers. You can
Okay.
go backwards if you want, but subtract the numbers to determine float. If it asks you, if it gives you this chart and says, what is the float? And it may say free float or total float, but it doesn't tell you the difference on here. Don't worry about it, right? Just float. Is the float for Charlie, you're gonna look at the relationship between early start and late start, or early finish, late finish, doesn't matter which one. And you're gonna subtract it and say, oh, there's 3 days of float for Charlie.
Yeah, so it's actually really easy to calculate if.
Yes, if it's given to you, it's really easy to calculate. You're creating it yourself, do a backward pass to figure it out.
It's 3 days of total float and 2 days of free float for Charlie.
Because this is a very small project.
No, because
No.
if it's 3 days, it has now, if it's 3 days, then project or F starts on the 9th.
That's right.
So if it's 3 days, it affects another project or another task.
It's going to affect another task, which
If
is a
it's-
free float. You're right.
So it's only 2 days of free float. Because if it goes to the 3rd, it affects the other task. So free float is the amount of time that it doesn't affect another task, right?
Yeah, so let's go forward then. Let's do a forward pass. So activity A is 3 days. And then activity Charlie is 2 more days. So that's day 4 and 5 would be the earliest finish. It's at the top.
Yeah.
5. And then, so I actually have days 6, 7, 8, 9, 10, 11. I have 6 more days until the project's over.
Mhm.
F takes 3 of those days. So I have 3 days of total float before I've screwed up my project.
Right.
I also end up with 3 days of, right? So doing the forward pass will give me some total float.
And right. So 3 days of total float,
3
2
days.
days of free float.
Well, in this case, because it's short, it ends up being the same.
No, because
If it's 2 days, that means I only have 2 days before I screw up this next one. And I actually have,
You're saying,
actually,
I'm saying that if we do 3 days of delay for Charlie, it affects Foxtrot.
no, but I think the difference is
Yeah.
she's saying you can end on the 9th and start on the 9th. You're saying you have to end on the 8th and start on the 9th.
so you actually have to do your math separate. So because, I said if we use 3, if we went 4, now I've stolen this float. That's the total float. I took.
Yeah, but I didn't understand that, I guess, is the
Okay.
key problem,
So-
because.
So flip your math the other way.
Because it's only 3 days of total float.
So we have 3 days before it affects this. And this has 1 day before Charlie has 3 days before it affects Foxtrot. And Foxtrot has 1 day before it affects the finish. Right? So if I
So-
wanted to add them up to total them, I would say that from Charlie forward, there's 4 days of total float. I've split it up with 3 for Charlie and 1 for Foxtrot, but there's 4 days of total float from Charlie forward.
But, okay, so I must not still be understanding. 3 plus 2 plus 3 is 8.
Mhm.
That's, so then the 9th, the 10th, and the 11th are 3 more days. So the total float is 3 days, right?
At Charlie.
That path.
Shannon, I have a question.
Yeah,
All right, I'm delaying the class, I think. I apologize.
Go ahead, ask your question.
how many questions are there on, this topic?
How much do I need to know this?
Probably 5,
Oh.
but it'll be like, what is the critical path? Calculate the critical paths. Calculate flow, know what forward pass is and what backward pass is.
What is a critical?
this number,
So-
this way, this number.
So I won't have to know this to work for NASA.
No.
That's the.
But
that's
maybe-
the finish,
Why is it
right?
read the critical?
Maybe.
Calculate flow for a
There's
specific
1 day.
activity
No,
for path.
1 day.
so I'm sorry, Olivia, say that.
They're asking for flow for a
What was the
specific
biggest number?
activity or
Yeah,
for a path.
They'll ask for float for a specific activity. Let's talk offline afterwards and we'll get free float, total float worked out. So know the definition. If you're taking the exam, the definitions for free float and total float, but they're just going to ask about float when they calculate something. They won't distinguish between. Okay. And when they give you this, just calculate float by comparing the difference between the top and the bottom, either the start or the late, but the top and the bottom. We're gonna get offline though. We're gonna get this figured out.
Okay.
We will.
Problem is you're a math brain. Forget that.
No, your math is not there. Okay. Not only durations, leads, lags, dependencies, relationships we have to consider. There are some special intervals that you also have to consider in making your schedule. So PMI says negotiate when these occur so that it fits with your schedule. Everything can be negotiated. Everything can be tailored in project management, okay? Everything can be tailored. Believe it or not, that's a test question. So these are certain intervals. Make them fit into your schedule where it fits into the schedule. So negotiate these times. Blackout times. So blackout times is when no changes can happen. User testing. When you send a document out to all of the combatant commands and say, edit this, stop writing. You can't make any changes till you get the edits back, right? So blackout times. And so it reduces risk because you're not getting feedback on old information. If you don't stop working, you just get feedback on old information that may not be relevant and the users aren't testing what they're really supposed to be testing. So blackout times, no changes get made by the team. Go live. We finished, we're rolling it out, we're moving. Go live is a special interval that we may account for on our schedule. Iteration H, I don't know anybody who calls it iteration H, but hardening sprints is a pretty common term. And a hardening sprint is where we're just tying up the loose ends. So we may have conducted a sprint and the feedback, the user's like, I like all of that, except like that color doesn't work. Can we change the color of that button? You're like, yeah, I'll change the color of that. You know what? It's not stopping me from moving on. I'm moving on with the next sprint and it's in the backlog to change the color of that button. Not critical, not important. If I have time, I'll pick it up. But maybe we get enough of those things that let's just stop, have a hardening sprint, tie up all those loose ends and then move forward again.
Take care of like your technical.
That's a hardening sprint. All this information we're considering to make a schedule, right? It's a lot more than what you think. So now we have all this information. We know our leads, we know our lags, we know our durations. We know all those other times that we're going to have to stop work for something happening in there. We create a schedule and oftentimes we depict our schedule by something like this. It's called a Gantt chart. Gantt is the name of a person who made this popular, which is why it's always capitalized with 2 T's. And the Gantt chart is depicting what task we're doing when and a little bit of duration. And this one has green for being completed, red for not. You'll see some of them are partially completed, some red, some green on the task. I'm thinking most of you are familiar with Gantt charts.
Is it the same thing as a waterfall? Like when I see that, I think waterfall.
Waterfall.
Okay.
Where the name comes from.
Got it.
You see the waterfall happening right
I
there?
didn't know we were calling it a Gantt. Yeah.
Oh, you just called this a waterfall chart?
Yeah.
Well, Mr. Gant will be pleased to know that, except I'm pretty sure he's not alive anymore. It's been called the Gantt chart for a long time.
Just beginning as well.
So
Exactly.
there are a lot of software programs that create Gantt charts for you. Tell them durations, your task. Right? MS Project is a really common one, MS Planner. Anybody use MS Project? Sometimes the military is forced to use MS Project. It's clunky. It's
Microsoft.
But there's a lot of project management software programs out there now. They all do Gantt charts. Now, a milestone schedule is a schedule that depicts when just when certain milestones are. I think I have a picture coming up in like 2 that will show, but think about this and a milestone chart combined. This is just a look at depicting the schedule. It's kind of a Gantt chart, but not really. But it aligns with our WBS. So here we have our work packages. We have tasks and activities, and we have when they're happening. So we're able to see the green line across the top may be, we don't really use this for Agile, but if we did, that would be like the epic, the big line across the top. But so task 1, this is the name of our chunk. And then the activities underneath the chunk. You can see what's happening or when they're scheduled. This uses blue and red. Those who are color deficient and don't like green and red, right? We have some other options. This is another way to depict the schedule. And so here's another Gantt chart. But you see the little black lines that comes off of ID number 6 and comes down to the next 2, tells us we have a finish start relationship between those tasks. So which is ID number 6 finishes, 7 and 8 is going to start. So we can see the same when we come down to number 10. When number 10 finishes, 11 and 13 are going to start. Come down to 14 and 15, both have a finish relationship. Right now, 14 and 15 are going to finish at the same time. And when they finish, number 4, testing begins. So it has lines to show the relationships as well as when the tasks are happening and what their durations are.
7 and 8 don't necessarily have a start relationship. They just happen to both have a relationship with 6, correct?
Don't know.
Okay.
Whoever put it together would know. So right now they look like they're starting at the same time, but I don't know if they have to start at the same time or not. It looks to me like they intend for them to start at the same time. But I don't know if they have to or not based upon this. I would assume that, but I don't know for sure.
Based on the duration too, you only have like 1 day where you could push back task 8. So
Right. Number 7's going to take Wednesday, Thursday, Friday, and number 8's taking Wednesday, Thursday. So if they didn't start at the same time, it's got to start the very next day anyway. I don't know. There's no finish relationship. So what I can tell from there is they intend to start them at the same time, looking at the timeline they have. Don't know if it's mandatory or not. And then here's an example of a milestone chart. So they're just markers in time. Again, nothing's happening. They don't have durations. They're just markers on time. So if you take this chart, you overlay it with your Gantt chart, you get some more information. Just know this is where my milestones fit in with my task. It's a helpful tool. So this, let me back up to B. This Gantt chart now becomes our schedule baseline. This now is our baseline. We have the task. We know exactly when we're doing them. We know the relationships to each other. We know the durations. We know when we have blackout sprints. We know when there are lags and leads. And this becomes our baseline. So as we start comparing our project, how do we know if we're ahead of schedule or behind schedule? We compare it to our schedule baseline. These are charts that we often use to show whether we're ahead of schedule or behind schedule. The top one is called a burn down chart. You can see the line is going downward. The trend is downward. That's a burn down chart. And the bottom is called a burn up chart because our line is going in an upward trend. So burn down, burn up. The burn down chart may be reflecting, these are the tasks we have left to do. Right, so we started with a lot of tasks. As we've accomplished them, we've had fewer and fewer and fewer, and we can show over time that we have fewer tasks to do. The bottom one may be reflecting how much we've done. So over time, we started doing nothing. And then we have, looks like stage one, we have about 10, 12 story points finished. After the second one, we have a little bit more. Now, on these charts, the top chart has a light blue line that's a straight diagonal line. That's our baseline. That's what they plan to do. Oftentimes, it's a straight line. We're just going to knock them off at an even pace. That's not always the case. Like you'll know. On the exam, what you'll see is a baseline is a straight line. Occasionally, it's a little bit different, but almost always it's just a straight line. And then the green line, the squiggles, says what you've done. So you've been plotting your progress all along, and you're able to tell if you're ahead of schedule or behind schedule that way. The same at the bottom. The light blue line is the ideal, what they plan to do, and the red line is what they've actually done. Right? So let's look at this bottom chart with the red line because it's a little bit easier to see. I don't know why it says TAG. I don't know if that's a foreign word or they lost the S for stage. But at point number 2, are we ahead of schedule or behind schedule?
Behind.
Behind? Behind? Everybody agree we're behind?
Yep.
We've done less than what we planned to do. Our point is below the plan. So that means we're behind schedule. We've done less than we planned to do. So when we get out to point 4, are we ahead of schedule or behind schedule? Ahead. We've done more than we planned to do. So we're ahead of schedule. Just that simple. All right. So test questions, you'll be asked to read the chart. So be able to know if you're ahead of schedule or behind schedule. Okay. Oh no, we're behind schedule because we never have the like, oh no, I'm ahead of schedule. Sometimes that causes problems, but oh no, we're behind schedule. What are we going to do? What are we going to do? So there's a couple techniques for staying on schedule when we get behind. One is called fast tracking. In fast tracking, we're going to break those dependencies and we're going to add leads. We're going to start overlapping tasks. So let me show you what this looks like. We had planned to do tasks 1, 2, 3 in sequence. But now we've got to do them simultaneously. There's some overlap. So we're creating leads when we do fast tracking. So we'll be able to get everything done sooner. Because instead of doing them in sequence, we're going to do them simultaneously. Now, there's a reason that we wanted to do them in sequence. There's a reason that we had a dependency to do one before the other. And when we break those, we're taking a chance on something happening because there was a reason. So we increase risk in fast tracking. Fast tracking increases risk because we're breaking dependencies. What kind of dependencies are we going to look for to break? Mandatory or discretionary? Discretionary and dependencies is where we're going to look first. If I need to speed this up, I'm going to look for discretionary dependencies. Now, if this is my project and I have to speed this project up, what task do I really want to focus on? The task on the critical path. So I speed up a task that has 5 days afloat and I do it 3 days sooner. I haven't changed the timeline for my project. My schedule's still the same. So first, you look at task on the critical path. That's how you shorten the project. The critical path.
I feel like I'm starting to become a problem student.
No,
But,
no.
Can there be more than one critical path in the sense of a tie, basically?
Yes, because we may start off with one critical path, but maybe something gets so delayed. One particular task gets so delayed that now it has changed the critical path. So now I could have two paths that have the same amount of time, but I could have a change in the critical path because something went wrong and got delayed. And now that task has called, it wasn't on a critical path before, but because it got delayed, the path it's on is now the longest. So we actually changed the critical path. So it's simply the longest path. And if two paths have the same length of time, you have two critical paths. Moving a task on one and leaving that other one still the critical path will shorten your project. So if I simply need to move up what I'm doing and stop the whole, well, if your whole project's delayed, you're going to look at shortening the project to get back on track. And so you're going to look at tasks on a critical path. The other ones, it's great, you get done sooner, but it doesn't shorten your project. Okay, so know that fast tracking breaks dependencies on the critical path is where you want to look, and it increases risk. Okay, the other technique besides fast tracking, we call crashing. And crashing is where we shorten the time by adding resources. So I have 5 people on my team doing the work. Give me some more team members. Give me 3 more. 3 more. But we're going to knock this out. Authorize overtime.
Bribe,
Got to work weekends.
bribe the inspector.
Bribe the inspector. Bribe the inspector. So I'm selling a place.
Like you're really considering.
I'm selling a place in Chicago. The dryer quit working.
Love it.
Man, of all times for the dryer to quit working. Couldn't happen the day after we closed. Had to happen a couple weeks before we closed, right? So I need a new dryer. Home Depot's taken forever to get a new dryer. They finally delivered on the 16th. I need to be ready to close by the 25th. The guy's like, you need a stacking kit. I'm like, no, no, no. They told me I needed all these things. I bought a dryer and then, a list of things to hook it all up and put it together. Nope, you need a stacking kit. He's like, you can use the stacking kit you have now, but Home Depot requires me to install it using a new stacking kit. He's like, look, I'll just leave this in your living room and you can just hook it up, but I can't hook it up. I'm like, you can't leave it in my living room. It's a gas dryer. My kid there doesn't know how to hook up a gas dryer. No, no, you got to hook it up. Look, I'm closing. I don't have time to redo this, getting people to come back out again. You got to do it. He's like, I can't, you need a stacking kit. I said, I'll give you $100. He said, do you have cash? I wasn't there. My son's over here in the conversation. He says, I have cash. Cash? I'm like, yeah, will you do it? He's like, all right, but you have to tell Home Depot that I just simply dropped it, delivered it. Fine with me. He hooked it up, right? He hooked it up. Got $100. You got cash? Hooked it up. Bribery? That's what I felt like. Oh my God, I'm bribing this guy, but whatever. It was a tip for doing, right? You're not working for Home Depot now. You're working for me. I'm paying you as an employee.
So
Hook it up. He hooked it up, right? And so I said, okay, put my son back on the phone. He puts him on the phone and I'm like, why do you have $100 cash in Chicago? Are you walking around with $100 cash? All right. Crashing. Throw more resources at it, right? We got a construction project. I only got one backhoe. Give me 2. Give me another backhoe and another backhoe driver or heavy equipment operator. We're rolling this. We got to pick up the pace, right? That's called crashing. So where fast tracking increases risk, crashing increases cost. Paying for overtime, paying for additional people, additional equipment. So although we're catching up with our schedule, we're back on schedule at a cost to our budget.
I would assume with this one though, you would have to go get approval since it's increasing cost, that's right?
It depends. So maybe you have that in your budget, maybe not. Maybe you're allowed to authorize overtime as a project manager, maybe you're not. No,
You'll have a reserve and you're just consuming the reserve.
maybe.
Probably also depends on how big the cost is, right? So there's probably a threshold where a project
Hey,
manager.
guys, we can knock this out. I will buy you pizza and let's just stay late tonight and let's finish this. And then next week, the load's gonna be, or next month, it's gonna be much lighter. Take time off. Let me give you some extra time off next month. You just let's work it out here, right? So I may have authority to do that, right? Smaller. Take some money out of my pocket and buy some pizza. Okay. Now, so that's tracking and crashing and fast tracking when you're behind schedule and you need to catch up. Sometimes you're going to get behind schedule because something's about to happen, right? And so I'm trying to prevent, I have a supply and demand issue. That's what these are. I have a supply and demand issue. So smoothing, go back to supply and demand issue. Lisa is the only one on my team who has the ability to do this particular task. Lisa gets sick and doesn't come to work. Lisa finally gets told that her favorite cousin's getting married all of a sudden. Come on, come to Vegas with me next week. Come, we're going, right? And Lisa's like, I can't miss the wedding. I'm off next week, guys. Short notice, I'm out of here. And I'm like, well, no, these tasks are scheduled for next week. And now I don't have the resources to do it. What do I do now? Because if I wait, I'm going to get behind schedule. If I wait for Lisa to come back, she's going to come back all hungover and not even be productive when she gets back. So I'm missing 5 days plus 2 days of productivity. Come on, like I can't afford that. So that's what we're talking about with these two, right? I have a resource problem that I want to try to fix. So smoothing is a technique to help. Let me just throw the picture up here. It makes sense. So smoothing says, I'm going to adjust how I do the activities. Right? So I had planned to do task 1, 2, 3, 4, 5, 6 in that order. But because I'm missing a resource and I can't do task 2, all right, let's just change how we're going to do it. Let's move things around, smooth things over so that the resources I do have, I'll use. Right? So I'm going to pick the task to do. It's not how I had them scheduled, but because of when my resources are available, I'm changing when I'm doing that particular task. So instead, we're going to do task 1 and then 5 and then 6. And then we'll do 4 and then we'll come back to 3 and 2. So that's smoothing, just changing things around. Now, never on the critical path, assuming we have dependencies. Because I can't really move things. If there's a mandatory dependency, can't really move. Like task 2 has to come after task 1. It's on the critical path. I messed up, right? So we try to avoid activities on the critical path. In fact, PMI will say never choose activities that are on the critical path. Depends on there's dependencies there, right? So we're moving things around. We're still going to meet our scheduled deadline. We're still going to finish when we're supposed to with smoothing. Just changing things because of when our resources are available. And resources are people and physical resources, okay? Moving things around.
Why would you never move anything on the critical path if there's not a dependency? I understand you would potentially adjust the timeline for the total project, but if you can find a task that's on the critical path that doesn't have a dependency.
It's on the critical path that hasn't been.
Yeah, if you can find a task on the
Yeah.
critical path that doesn't have a dependency,
Yeah.
then maybe all along
I guess you're right,
asking why it needs to be on that.
because you followed the critical paths.
Yeah, so we could just.
I guess I was thinking of discretionary. That's what I was thinking.
Yeah,
Okay.
If there's an item that doesn't have a dependency, isn't it just on its own entire path?
on its own path.
Okay.
I want to be that guy.
Yeah, on your own path. Yeah, so it doesn't have a dependency. It's not related to anything. Now, sometimes instead of having a path with one task, we just stick it out in another path based upon where in the project it may fit. But really, it's got its own path. It's its own line of effort. It's not related to other things. So the critical path is going to assume they've all got dependencies. You don't really move them around. Now, in real life, you're going to look and see if you can, right? Because otherwise, delaying your whole project. And when you end up delaying your whole project, we call this leveling. And in leveling, it's forced to move things to match resources, but you really do break the critical path. You're going to extend your project. Because things happen and that you can't. The computers go down, you don't immediately go, give me another computer, give me another network, give me another, right? The electricity goes out, you don't immediately go buy a generator and bring it here and hook it up, right? So things happen sometimes that force us to get behind schedule that we can't make up because of resources. So leveling, things happened. Our durations got extended because of something related to resources. All right, let me see. All right, we're going to switch from traditional to agile scheduling. So this is probably a good time to break for lunch then. How much time do you want to take for lunch? We do 45 minutes again? We need an hour? An hour? All right, let's take an hour for lunch. We'll come back at 12:25, whatever time it is in England. 6:25, take a dinner break in England. We'll take a lunch break here in Illinois. All right, we'll take an hour. We'll start again at 12:25.
Yeah, just combine it.